Hello guys, welcome back to Maison African Motives. We are still on our revisions for mathematics N4. So this is the question paper that we just wrote in the November 2023 exam. So we shall quickly rush through our questions so that we'll see how we're supposed to attempt these typical questions. We're given the first part of our question, which is question number 1, that was to draw the graph of. We're given the first two graphs. All right, so let us check the first graph that you're given. And also you're supposed to even understand the type of the graph that you're going to have at the end before you even draw that graph that you're going to draw. All right, so anyways, if you have to check here, we are working with an ellipse in this case, because if you can check these two, they are different. All right, we've got 25 here, we've got 4x squared. But if we had the same values, if this was 4 and this is also 4, it was going to be a circle when it is like that. But anyways, that part, like I said, you can also see that when you are finding your x-intercepts and your y-intercepts. So the first thing is to determine your intercepts. That is the x-intercepts and the y-intercepts. We are given 4x squared over 100 plus 25y squared over 100, which is equal to 1. So this is over 100, which is equal to 1. So it's either you can clear the fractions if you want. This one is a choice, but what we just need here is to find the intercepts. That is the x intercepts in this case. All right. So the x-intercepts, we understand they are at a condition that this y must be equal to 0 in order for us to determine the x-intercepts. We know that y must be equal to 0. So if this part is a 0, because the moment you write a 0 here, that's 0 squared, and everything here is affected by that 0. So it means we are not going to have anything from the part of y. We are going to be left with only x. So we are going to be left with 4x squared over 100, which is equal to 1. If you want, you can just simplify this on your calculator. You see that you're going to obtain a 0 in that case. So to find x, we can even cross multiply. This is over 1. So that means we can cross multiply in this case. 1 multiplies this side, 100 multiplies this side. So you're going to have 4x squared, which is equal to 100 times 1. That was going to give us a 100. We can even divide by 4 before we determine the square root in that case. That is, in this case, that will be a 25. The square root, both sides, to determine the value of x, we're going to obtain plus or minus 5, the square root of 100. That means we've got two possible values of x, a minus 5 and a plus 5. When y is equal to 0, for the y is equal to 0, you have got the x-intercept that has two possible values. So it is the same thing that you're going to have for the y-intercepts in that case. So in order for you to have the y-intercept this time, x must be equal to 0. So if we are referring x to be equal to 0, it means we're going to substitute a 0 here, and 0 squared, that's a 0, and anything when multiplied, or if you divide 0 by any number, we're going to have a 0. So meaning to say this is going to be eliminated. We remain with the part of y, this one, whereby we are having 25 y squared over 100, which is equal to 1. Like I said, 1 is same as 1 over 1. So you can be able to cross multiply 1 times 25 y squared. That's 25 y squared, which is equal to 100 times 1, which is 100. So you can divide by 25 by 25 both sides, so that we can be able to determine or to have the square root. All right, 25 into 100, that's a 4. So in order for us to have the value of y, we're just going to introduce the square root, which is going to be plus or minus 2, the square root of 4. So as you can see, we have got the y value. The y value is in actual sense, two possible values. The x values, two possible values. But these values, they are not the same. If you have to check here, this is 2 and this is a 5. So that means we are having an ellipse in that case. It's not a circle. If it was a circle, we're going to have same values, like x can be plus or minus 2, y also can be plus or minus 2. If it is a condition like this, you know that you are having what? you are having a circle for that condition. But in this case, we are not having, because there are two different values that we are obtaining. Remember, we obtained that x is equal to plus or minus 5 and y is equal to plus or minus 2. They are different values that you are obtaining. Like they are not the same. This is 5, this is 2. So we know that. All right, let us just take this way. I'm just going to have it as a sketch of what was going to happen. Let's say we have got our values of x taken from 0 to positive 5. In the x-axis, we've got 1, 2, 3, 4, 5, something like that. Then you've got maybe -1, -2, -3, -4, -5, -6. The y values taken from 1 up to 2, and also on the negative, -1, -3. So as long we are to accommodate these values to say our x is supposed to be plus 5, or we can have it at -5, the y value at 2, or it can be at -2. That's, remember, the intercept, this one will be 0, x will be equal to 0. Then it's 0 minus 2, 0, 2, -5, 0, and 0, 5. These are the points that are necessary, all right? With these points, we're supposed to actually join them, and we form, or we are going to have this type of a graph, which is actually an ellipse. And as you can see, an ellipse, we can see that it is symmetrical about the y-axis, which, consider the y-axis, this part can close the other side. Also, it is symmetrical about the x-axis, all right? So, but the question here was not asking about that. It was just for you to draw this graph. All right, so this is the graph for 4x squared. It was given as 4x squared over 100 plus 25y squared over 100, which is equal to 1. So this is what you're supposed to have at the end. All right, let us consider the other part. Let us consider the other type of the graph that you're given. This time we're asked you to draw the graph of this part. Okay, if you have to check between the two, this was a positive, this is now a negative. So it's like we're having the same thing. But here, you're going to see that this one is not going to be an ellipse. It is not going to intersect, or it is not going to give us a complete ellipse or a complete circle, just like what we are used to. Okay, I want you to see what is going to happen on this. We are given this as 4x squared over 36 minus 9y squared over 36, which is equal to 1. So let us consider the idea that we are supposed to determine, as usual, our x-intercepts, all right? So we're going to have our x-intercepts on a condition that y must be equal to 0. So asking yourself that this y is equal to 0 here, we're going to have 0 squared. Definitely this will be equal to 0. So I'm just going to be left with this equal to the right-hand side. So I'm going to be left with 4x squared over 36 equal to 1 over 1. Just like the previous cases, you can see it's just a repetition that we are having here. That's 1 times 4x squared, which is going to be 4x squared is equal to 36 times 1, which is 36. So we can divide by 4 in this case. That means we're going to have x squared equal to 4 into 36, which is 9. And to determine the x values, it will be plus or minus 3, the square root of what? That is the square root of 9. We've got two possible values, a plus or a minus 3. All right. If you were to consider the same for the y-intercept, this is what was going to happen. Let us see what was going to happen here. Just act as if you do not know what is going to happen. We know that x is equal to 0 for the y-intercepts. All right. We put a 0 in place of x. That means this is going to be 0 squared, and so whatever that we have there is going to be 0. So we are going to be left with these two. Take note, the negative there is there. Take note of this negative. We are having a negative, so it's going to be minus 9y squared over 36, which is equal to 1, and this is 1 over 1. And if you cross multiply, that is going to be minus 9y squared is equal to 36 times 1, which is a 36. We can divide by -9 by -9. That means we are going to have y squared being equal to 36 over -9. That is a -4. So the moment we are to try now to determine the y values by introducing the square roots. That is where you're noticing that because here there's a negative and I can't determine the square root of a negative, it means there are no solutions there. We can't determine the square root of a negative value. All right, so meaning to say we are having imaginary values there. Okay, if we are to determine, let's say, square root of -4 like this, that's meaning to say here we are not having any solution because it is giving us a math error to show that there are no possible values that can be obtained from this solution that you want to have. So it means we've got infinity values in this case, all right? So the values of y are actually, they are infinity value. You can't even determine anything about this. So how do we draw this graph now? How are we going to end up with? All right, so this is what is going to happen. Okay, remember we said x is being taken at what? We just need these two. Our x-intercepts, we said our x is at ±3, and the y value, we do not have the values of y. It's actually up to infinity, ±infinity. Okay, if we are to consider this, it means we are supposed to, okay, this is our Cartesian plane where we're gonna have our y and x axis. This is our x, this is our y here. All right, so let us just consider our points 0, 1, 2, up to 3. All right, so for 2, 3, and also a 4, -1, -2, -3, -4, 1, 2, 3, and so on and so on. So this one, we are not worried because we do not have values there. Okay. So we are supposed to have our points at 3 and at -3 in the x-axis, because these are the x-intercepts at point 3 and at point -3. This is where we are supposed to have our points. All right. So if we had a point here, let's say we had a value here, and let's say we have a point here, we are going to join them and complete, maybe it's a circle or maybe it's an ellipse, maybe our points, they are at 1 and -1, we're going to have an ellipse in that manner. But in this case, we do not have the y values. So our graph is not going to be taken back this way because there is nothing that can be taken in place of what? Of y. There are infinity values. So meaning to say, we are going to have our curve like this, all right? We're gonna have our shape going this way and also in the other way, going this direction, all right? And from this -3, going this direction and also going this direction. Remember the idea that we talk about the asymptote, that we do not have values that can be taken. So if it was a concept of you calculating your asymptotes, this and that, but what is important in this case is that the y values, there are no values in between here. There are no values. So that's why we are seeing our curve going this way and also the other way, because it cannot reach. The moment you show it this way, it means there's a possibility for these to meet, but these ones, they are not going to meet, okay? So they are going to be separated by the equations of the asymptotes of these lines, of which you do not worry about that. If you are to draw, do not worry about writing your equations of the asymptotes. All right, so this was our graph of 4x² over 36 minus 9y² over 36, which is equal to 1. Just write your equation. So this is what is important. You can obtain your full marks with this information. You can have the full marks. All right. Let's consider question 1.2. Let's check what are they trying to say on 1.2. 1.2, we are given that is just got 4 marks. All right, so this is 1.2, just got 4 marks. They are saying we are given here a rectangular piece. So here we've got a rectangular piece of sheet, all right, is 10 meters long and 5 meters wide. If the area doubles when the length and the width is increased by the same unit of length, by the same unit, we do not know that length that is going to be increased. What are the new measurements? What are the new measurements? All right, let's take this. This is a word problem. Remember the idea of word problems. You generate the equation to what you're given. We are given a rectangle which measures 10 by what? By 5. All right, so this is our question 1.2. So we're given that this rectangular piece of sheet metal, it measures 10 meters by 5 meters. This is what we have. We've got a rectangle here, which measures 10 meters, the width, the length, and 5 meters wide, which is the width. Then they are saying that here, if the area doubles, which means the area to double is like twice of what was there, okay? That's a double. If we have got a 2, double that, you multiply by 2. If you've got a 3, double that, you multiply by 2. So a double of anything is twice of that. So they're saying the area doubles when the length and the width is increased by the same unit of length. So to double, it means here we are going to have another rectangle, all right? Another rectangle here that we are going to have another rectangle. So the area of this first rectangle, this is our first rectangle, this is the second rectangle. They are saying this area, it doubles, meaning to say, if you calculate your first area, let's say this is our area 1, what it means is that our area 2 is equal to 2 times of area 1, that is to double. We are doubling the area, okay? Twice of the area that you had from the first one. But they're saying it has to double if we increase these dimensions of this rectangle by what? By the same unit of length. So we do not know that length that we are going to use. But what we know is that we are going to increase this by a certain length. So to increase is to add, okay? So maybe we just add 5 or 7, or we do not know. So that part that we do not know, let it be what? Let it be x. So it means we've got 10 plus x. The same, the width also is being increased by what? By the same unit of length, by the same length. So we are told that this is being increased by the same length, all right? It is increased by the same length, x. So if it is increased by the same length, it means also on your width, we are going to have the same thing, all right? We are going to have plus x. So this is going to be 5 plus x. All right. Now, let's consider the statement about area. Since we are told that this area, it has to double, what was the first area in the first place? Our area 1 from this rectangle. Our area of a rectangle, you know that it's length times width or length times breadth. So meaning to say our first area from this rectangle is length of 10 times 5, which means we are going to obtain an area of 50 square meters. This is our area. But our area 2, now this area 2, that we know that in calculation, it was supposed to be taken as the length times the width, just like the previous case, length times width, whereby our length is given, now it is increased by x. So it's going to be 10 plus x, all right? The width, it is increased by what? By x also. So it's going to be 5 plus x. So this was supposed to be the expression for area of the second rectangle. This is the expression for the area. This is actually the numerical value, not the expression, because we are having the exact value there, a number that is representing what? Area. But we are saying in our relationship, they are saying that the area of this rectangle now is supposed to be equal to 2 times area 1, which is double the area 1. So meaning to say this is our area here, our area 2 from that statement. Area of the second rectangle is double the first area, which is 2 times. So it means this is our area in terms of x for the what? For the second rectangle, which is the one that has been changed in terms of the units, which is given as 10 plus x into what? Into 5 plus x. This is the expression for the area. It must be equal to double the first one, double this our first area, this one, double it. So meaning to say it is going to be 2 times what? 2 times 50. That is to double the area. So we have formed an equation. The moment we have done this here, we have formed an equation. All right? So the moment that you have formed an equation, what are you supposed to do? You are supposed to solve it. All right? Because you have formed an equation. So we are supposed to solve this equation in terms of x, all right? So we are going to expand our brackets, then we'll tell what type of equation that we have later on. So let's multiply. Remember, 10 multiplies everything. That is going to be 10 times 5, which is 50. Multiply 10 and 5, which is 50. 10 times x, which is 10x. We move on to x times 5, which is 5x. Then x times x, that will be x squared, is equal to 2 times 5, which is 100. So as you can see, the highest exponent there is being 2. So the moment that we see that, we think of the quadratic equation ax squared plus bx plus c is equal to 0, whereby we are supposed to have one of the side equal to 0 of this quadratic equation. So meaning to say, we can first arrange this side. As we are rearranging, we also take the 100 this side, because we must be left with a 0 on one of the given sides. It must be equal to what? To 0. So this is going to be x squared. All right, let's collect our like terms here. We've got 10x and 5x. So if we add 10 and 5, this was going to give us 15x. So we have got 15x. Then let's transpose the 100 to the other side so that we remain with what? A 0. Remember, we want this format, ax squared plus bx plus c is equal to 0. So if we transpose 100 this side, we are going to be having 50 minus 100, which is equal to 0, like that. So that will be x squared plus 15x. 50 minus 100, that's minus 50. In this case, right? That's minus 50, which is equal to 0. So this is a quadratic equation. As I said before, you're supposed to solve this equation depending with the method that you are capable with. But as you can see here, we do not have factors. So it means factorization was going to be difficult, but it was not going to work for us. So the best method was to use the quadratic formula, which states that x is equal to minus b plus or minus the square root of b squared minus 4ac. Everything is over what? Over 2a, whereby if we take in this, the a is the coefficient of x squared, which is 1 in this case. The coefficient of x is our b, and c is the constant. So we've got our a, our b, and our c. So we're just going to substitute into the formula. So x is equal to minus b, that's minus 15. All right, so it's going to be minus 15 plus or minus the square root of b squared. So this is 15 squared minus 4 times a, which is 1 times c, which is negative 50. All right, so this whole part is over 2 times a, which is 2 times 1. So with this information, or with this part that we can see here, we can also just try by all means to simplify the part that is under the square root. This part under the square root, just leave the square root as it is. Just simplify the numbers that are under the square root and just obtain a single term. It can be of advantage in your simplification. I'm not saying it's wrong for you to just simplify at once, but you can just to simplify these numbers under the square root. That is 15 squared. So you've got 15 squared minus 4 times 1 times negative 50. 4 times 1 times negative 50, like this. All right, so this is going to give us 425. So we are going to obtain 425. Everything is over 2 times 1, which is a 2. The most important part of doing this is that sometimes, remember, you'll be dealing with complex numbers whereby you can't determine the square root of a negative. And it is very, very important that you see the number under the square root. Is it a positive or a negative value? Then you can simplify to obtain your solutions. All right, so you're going to have a fraction. Let's start with a positive, negative 15 plus the square root of 425, like this, everything over 2. So this is going to give us 2,808.07, which is 2,808. Okay, to 3 decimal place, it's going to be 2,808. All right, so because okay, I want to prove this point, so I'm just going to store this value. I'm just going to store it. So to store a certain value, for you to use it later on, you can just press this shift. You press this store, this one, it's written store on this one. So once it's right, the store on this part on top there, it's written STO. you can store it any of these letters A, B, C, D, E, F, X, and Y. So in this case, I want to put it in A, so I'm going to store it in this letter A. So I'm just going to press this one. So my answer is now stored in the in this part where there's A. I'm going to use it later on. That's why I'm doing this. All right. Anyways, let's find the negative one. For the negative, we are going to have our X being equal to, just gonna have a negative this time. So that's negative 15, negative the square root of 425, everything over 2. For a negative, we are going to obtain negative 17,808 because the 7 is going to change this into 8. So that's negative 17,808. So if we are to check of these values that we are having, the first thing that we are to notice is that we are having a negative. And X, the X that we are talking about, it's an extension, it's a length. We are talking about an extension. We extended our length by X. So it can't be extended by a negative in order for us to have a doubled area from what it is. So meaning to say our X is going to be 2, the positive. Our X cannot be what? Cannot be this value of what? Cannot be this value of negative 17,08. So meaning to say our X is going to be 2,08. But the question here, let us answer the question. Like I said, I'm going to use that value, the one that I stored on the calculator. I want to prove something from that value. But let's answer the question here. The question was not about finding X. The question is, what are the new measurements? What are the new measurements? On this rectangle, we said our X, the one that satisfies everything here, is the X, which is a positive. This one, 2,08, 2,808. This is the X that satisfies our given statement. But what are the new dimensions in this case? So the new dimensions, we have to go back to the rectangle and replace back our X. Remember, the new dimensions, they are supposed to be given as 10 plus X and also 5 plus X. So meaning to say on each dimension, we're just going to add X, 10 plus X and also 5 plus what? 5 plus X. Those were the new dimensions of the rectangle. So from 10 plus X, it means the new dimensions. All right, so the new dimensions in this case are going to be the first one. From 10 plus X is going to be 10 plus 2,808. The second one from 5 is going to be 5 plus 2,808 because it was 5 plus X. So we have the value of X, which is 2,808. So this one is going to give us 2,808. This one was going to give us 7,808, like that. Okay. So if we are to now conclude to see if truly this is exactly what we are given about this statement. Remember, they are saying for these new dimensions that we have, if we have these new dimensions, the area is going to double. That is what we're given. The area doubles when the length and the width is being increased by what? By the same unit. It doubles. So we want to check that if truly we have got these new dimensions that we have, because we said these are the new dimensions, 12,808 and 7,08. If we multiply these two, we are supposed to obtain what? Double of the area, which is 100 square meters. Remember, the area of the first rectangle is what? The area of the first rectangle, we said it's 50. So double this, it means our area must be 100, okay? So if we double, it means we are multiplying by 2. So we want to prove that if we multiply these two, we must get what? A 100, okay? But now these are rounded values. These are rounded figures that we see. So what you do is that you're going to use the exact values, not rounded figures. That's why I had to store that value. Remember, I stored that value at A. So if I want to take that value that I stored at A, I'm going to press this button, that is recall A, like this. So this is the value that we had 2, this, all right? So the first one, we are supposed to add what? We are supposed to add 10 so that it becomes, so this is what we're going to do. It is going to be 10 plus recall A. We recall that A. Remember, A is where we have 2,80, the original value, okay? Times The second one, which is 7, comma this, which was taken from 5 plus that value. So we're going to take 5 plus that value that we stored at A, which is 2, comma this. So if we multiply this, we're going to obtain what? 100. This is to show you that truly the area, when it is being, when the dimensions are being increased by the same unit of length, they are going to double, okay, from this condition that we are given. So if you are to use these ones now, like I said, these ones, they are not going to give you the exact value, because we know that area is length times, if you are to multiply 12, 808 like this times 7, 808. As you can see, it's not going to give us exactly 100, but it's an approximate. Goes to the nearest one number, you can see that it's a what? It's a 100, okay? So that is the meaning of the question that you're giving. But if you want to obtain the exact 100, you use the original values, just like what I did, guys, to show you the part that I was showing you. All right, so that was a question 1.2. 1.3, we were given to make X the subject of the formula. All right, this is X the subject from this one. Okay, let us just find a space where you can just write this. That's question 1.3. We are given that T is equal to e to the exponent of 2x plus 1. This is to the exponent of 2x plus 1 like this, over e to the exponent of 2x minus 1 like this. And from this, we are asked to make to make X the subject of the formula in this case. All right. So what can we do? If you have to check, we've got a fraction that we can consider removing or clearing of the fractions, where we can even cross multiply to remove the fractions first. All right. So if you are to cross multiply, T is going to multiply every term on the denominator here, which is e to the exponent of 2x minus 1. So it's going to be T times e, which is T e to the exponent of 2x, then T times negative 1, it multiplies everything. So you're supposed to actually open a bracket, okay? Which is equal to 1, multiplies everything also on this side. But as you know that if you multiply by 1, it does not change anything. It remains, everything remains as it was before. All right, our major issue here is to make X the subject, or to solve for X. So if we were to take this part with X to one side of the equation, because you can see that here we've got X and we also have X on this term. Let us try to take these terms to one side of the equation, transpose this one to the other side. We can also transpose negative T to the other side of the equation. So this is going to remain T e to the exponent of 2x. If we take the e to the exponent of 2x this side, it becomes minus e to the exponent of 2x, which is equal to, already here, there is a 1. And we transpose the negative T to that side, it becomes what? It becomes a positive T. All right. Now let us consider to say, we have got e to the exponent of 2x, the one that carries x. Because remember, we want to make x. And the part so far that is having this x is the part of e to the exponent of 2x, the part that is of e. So we can factor out that term, or the common term that is having our x in this case, which is e to the exponent of 2x. If we factor out this out, what does it mean? We are simply going to divide. Remember the concept, guys, on your factorization, because we are saying this here is a common term, this here is a common term. So if we factor out that common term, it means we are going to be left with the t minus, here the same, there's a what? There's a 1. So you're going to be left with t minus 1 if we divide, which is equal to 1 plus t. You can write it as 1 plus t, or you can even write as t plus 1. It's one and the same thing. Or you can just leave it as what? As 1 plus t, like that, okay? You can just leave it as 1 plus t. Okay, now at this stage that we are asking ourselves to say, how can, because we still need the x, but still it's still under the e. So what can we do? We can remove the bracket. Remember, it's a multiplication here, so we can just divide by the bracket of t minus 1, both sides, by the bracket of t minus 1. So this will cancel. We remain with e to the exponent of 2x, which is equal to 1 plus t, everything over 1 over t minus 1. All right, this is over t minus 1 here. This is over t minus 1. Okay. In most cases, the question was supposed to be given at this stage, this one. This is how our questions in most cases, they were supposed to be given as where you are supposed to make X the subject at that stage. And we understand that if you are given E, to remove the E that we have here, we introduce ln both sides, the logarithms, which is ln in this case. So we're going to introduce ln this side and also ln this side. The moment we are introducing the ln, it means we can be able to drop this exponent to multiply the ln. So that will be 2x, the ln of E. So it's supposed to be 2x ln E like this, but we understand that ln E is equal to 1. So 1 times 2x, it remains as what? As 2x. So this will be 2x is equal to the ln of, this is now a single term, a single log, which is 1 plus t over t minus 1. So like I said, this is a single log. So you can find x by dividing by what? By 2 both sides. You can just divide by 2 both sides to have the value of x. So therefore, our x was going to be given as the ln of 1 plus t over t minus 1 like this. Everything over what? Everything over 2. Or you can even write this as, if you want to avoid dividing by this 2, you can just write as x is equal to 1 over 2 of ln 1 plus t like this over t minus 1. You can even write it that way. It's one and the same thing, just one and the same thing, okay? So that was it. Yes, we've got x as the subject. In this case, we've made x the subject of the formula. It was just issue of cross multiplying, collecting the terms with E or with X on one side of the equation, so that we can be able to factor that term and make our X to be the subject of the formula, as we can see. All right, that was it, 5 marks for that. And the other part, 1.4, was to solve for X. All right, so for X, if 12 to the exponent of X plus 1 is equal to 36. All right, which is again 5 marks for this. Okay, so that's 12 to the exponent of X plus 1, which is 1.4. So we have got 12 to the exponent of X plus 1, which is equal to 36. Remember, on this note, what you can do is to introduce your logarithms. And like I said, to introduce your logarithms, you choose, it's up to you. You can introduce a log, or you can introduce the ln. Ln is best, yes, to use on a condition where we've got E to the exponent of whatever that you have. It's best for you to introduce a ln. But when solving a normal equation like this, you can even just introduce your normal logarithm in this case. So just gonna write log here and a log on that part. The moment you introduce the log, what happens? We drop the exponent, just like what we saw on the ln. It's one and the same thing. So it is going to be x plus 1, the log of 12, which is equal to the log of 36, okay? So as you can see, the log of 12 has nothing to do with x, it's just multiplying. So you can remove this by dividing both sides by the log of 12 by the log of 12 both sides. So this can cancel. We remain with x plus 1 equal to log 36 over log 12. All right, so you can simplify this on our calculator. It's not like something that is difficult. Just use your calculator here. Use this log of 36, all right, over the log of what? The log of 12, like this. So this is going to give you 1,442, something like that, 1,442. Then to find x, you're just gonna transpose the 1 to the other side of the equation. It becomes a negative on that side. So x is going to be 1,442 minus 1. This one is going to give us 0,442. So our x was going to be 0,442. All right, to 3 decimal places. So that is how we could have calculated the value of x. I think this one was just a nice and direct equation that you're given. And I said you can also be able to prove your questions, all right, to prove your answers. If you use exact value, like if we are to use this, let's get back to this, our answer here. It means 12 to the exponent of x. If we say 12 to the exponent of x, which is the answer that we got, plus 1, all right, plus 1 like this, we must get this 36. This is equal to 36. So this you can be able to prove and see if your answer is exactly the one that gives you what is on the right hand side from what you're given on the left hand side. Okay. Let's see the other part. So that was our question number 1, the whole of it, the whole of our question 1. Then question 2, we are given to solve in this case. All right, solve for x and y using complex numbers. All right, given this. So these are actually determinants, but we are supposed to use complex numbers to solve, but we are given a question under determinant. The determinant of this is equal to the determinant of this. What does it mean? All right, so let us have our question down. But I think we managed to talk about this type of a question just before we wrote our exams of this nature. So we're given that the determinant of x j like this, yj like this, minus 3, minus 2, okay, is equal to the determinant of where we are given it as x minus y, and this is a j, this is a minus 4 and a 2. So these two, they are equal, the determinants. All right. Remember, how do you determine a determinant if you are given A, B, C, D? The determinant of this is the product of this major diagonal, this one, which is AD minus what? Minus BC, the product of these two. So you're simply finding that same way that you used to calculate your determinant. So you're going to multiply these two in the major diagonal, all right? Which is going to be minus 2 times x times j, minus, you multiply these two, that is minus bc, you multiply these two, which is yj and minus 3, okay? That is yj times minus 3 like this. This must be equal to the determinant also of this part, the major diagonal, these ones in the major like these ones. You multiply them together. So that is 2 into x minus y like that, minus, you multiply the remaining ones that are in the minor diagonal, these two, all right? The order does not matter, just multiply these two, which is minus 4 times j like that. So you have formed an equation, as you can see, from the determinant concept, because these two determinants, they are the same, they're equal. But the moment that you have formed an equation, it's no longer about determinants. The determinants, these lines here for determinant of this, they helped you to use the determinant formula, this one. But once you have used this formula, this equation, whatever that you have, forget about the determinants now. This is now a normal complex equation. You are now under complex numbers. You are now dealing with a complex equation in this case. So how do you solve such type of an equation under complex numbers? We are now back to the idea of our rectangular form. Remember, in rectangular form, I told you that there's no way that we can have two things that are a plus jb like this is equal to x plus jy like this. Once these two are in rectangular form and they are the same, you can equate the real terms together, meaning to say a must be equal to x. The imaginary terms together, meaning to say b must be equal to y. That is the condition that we know in this type of an equation if you're dealing with what? A rectangular form. So this is what we need. So we're going to work with the left-hand side, find our real and imaginary terms, all right? So let's multiply, in this case, minus 2xj. In this case, it's gonna be just minus 2xj. Minus and minus here, that's a positive, so it's going to be positive 3yj like this, all right? Which is equal to, if you take here, there is no j in this case, or I, or what, there is no imaginary, but that's our real term. This is your real term where we do not have a j. So you can choose to expand your brackets. Yes, it's fine, or you can just leave it like that. 2x minus y like this. All right, minus and minus, here it's a positive, so it's going to be positive 4j like this. Okay, so as we can see, on the left-hand side, we cannot properly see the real term. We do not have actually the real term. We just have the imaginary, because this is a j and this is a j. So it means the real term, because we are supposed to have it in the form of a plus jb, a plus jb, or a plus bj. We do not have that. So meaning to say the real term is a 0 in this case. So we are going to have a 0 as our real term. Then the imaginary part now, which is the imaginary term, is going to be plus j. We will factor out the j, which is common, because there is a j here. There's also a j here, which is common. So you're supposed to factor out this j so that it gives you minus 2x plus 3y like this, which is equal to your right-hand side. You can properly see your real term, which is 2 into minus x, 2 into x minus y plus 4j like this. All right. So now that we are at this stage, we can go back to this idea that I was referring to, say, as long we have got two equations in a rectangular form and they are equal, we can equate those terms in rectangular form in a real and the imaginary. So the real term, the part that do not have a j, the one that does not have this j, that's a real term, meaning to say our real term in this case, that's a 0. The one that does not have or do not have this j, that's a 0. And our real term this side is this part. So you have to equate the real terms together. That is what I'm trying to say on this one. All right. So this one is our real term. And on this side, this is your real term. These two, they are supposed to be equal because they are real terms. All right. They are the only real terms that we have. So it means, therefore, 0 is equal to, so let's say from real terms. All right. So from real terms, we are going to see that 0 is going to be equal to 2 into x minus y, which is, we have formed an equation from there. All right. Let's see from the imaginary terms. All right. From the imaginary terms. All right. So we've got the imaginary terms. All right. So from the imaginary terms, the one that has got a j, all right, we're going to consider the part that has got a j. So this is where we have a j and we also have a j. So we're going to equate what is remaining. This part is affecting our j and it's a positive on that part. So we are going to take it as minus 2x plus 3y like this is equal to what is affecting j on the other side of the equation, on the right-hand side. J here is affected by what? By 4. So you take the coefficient of that, which is a 4. So as we can see, guys, we have formed two equations by knowing this idea that the real terms are equal, the imaginary terms are also equal. It gives us now two equations whereby we can solve for x and y. This is no longer, again, at this stage, this is no longer about complex numbers. This is no longer about determinants. You are now back to your normal equations. How do you solve your equations and so forth? All right, so let's first work with our equation 1. We can see that from equation 1, we can expand 0 is equal to 2 times x, or even you can just divide by 2 because there's a bracket here, okay? So you can divide by 2 by 2. That's 0 is equal to x minus y, meaning to say that if you transpose y to that side, it's going to be y is equal to x. So this is what we have from equation 1. We can see that from equation 1, y is equal to what? Y is equal to x. So if y is equal to x, we can substitute that in equation 2 because we know that y is and x, they are the same. So minus 2x plus 3, y is equal to x. Or you can even substitute x, whatever that you want to substitute, because they are the same. So if y is equal to x, it means we're going to have this as 3x is equal to what? Is equal to 4. Minus 2x plus 3x, this is positive 1, which is positive x is equal to 4. But remember, I said y is equal to x. So if x is equal to 4, it means also y is equal to 4. Yes, you can substitute in whatever equation that you want, but you're going to see that these are the possible values that we are going to have at the end. All right, so the question here was for us to solve for x and y. So these are the values of x and y. So as you can see, they are the same. We've got the same value of x and also the same value of y in that case. So this is how sometimes, yeah, our determinants can be like. So this one was a combination of determinants and complex numbers at the same time. The determinants, they give you an idea how to determine the determinant. The complex numbers, they give you an idea how to solve equations that are under complex numbers. And when you're solving your equations, it's about the method that you're going to use, depending with the one that you understand that you're going to have, depending with the one that you're going to have. I don't know which one are you going to have. Are you going to be working with elimination, substitution? That one, it's up to you. All right. But that was a combination of what? Of two things, the determinants at the same time and what? Complex numbers. All right. Let's check 2.2. 2.2 is just to simplify, given that, all right, we are given Z1 and Z2, which are in polar form. So if you have to check here, your Z1 and your Z2, they were in polar form. Then you're asked to determine Z1 and Z2, the product of Z1 and Z2, then Z1 over Z, and leave your answer in polar. Already it's in polar form, so this one was just a direct person. You can even answer it here, 2.21. So Z1 times Z2 means we are going to multiply our Z1, which is 4, angle of 30 degrees like this. We multiply to Z2, which is complex number 2, which is 2, angle of what? Of 60 degrees, okay? So remember in the polar form, I told you that you can be able to multiply the numbers together. So it's going to be 4 times 8, 4 times 2, so which is 8. Then the angles, I told you that you add the angles. So this will be 30 plus 60 degrees in polar form, all right? So that will be 8, angle of 30 plus 60, which is 90. So the angles you add. If you are dividing, you subtract. So it means 2.22, it was going to be direct again, Z1 over Z2. This was going to give us Z1, which is 4, angle of 30 over Z2, which is 2, angle of what? Of 60. So likewise, the numbers, you divide them by the angles, you subtract. So this will be 4 divided by 2, which is 2. Then the angles, you subtract 30 degrees minus 60 degrees. This one minus this one. So it's going to be 2, angle of 30 minus 60, which is minus 30 degrees. Okay, so that was going to be our resultant or our answer in polar form. As you can see already, it's in what? It's in polar form. So that was just direct. All right, 2.3, simplify. We are asked to simplify 2j to the exponent of 16 minus 9j to the exponent of 3. All right, so if you have to simplify this, we are going to see that, all right, this is 2j to the exponent of 16 minus 9j to the exponent of 3. Remember that to the exponent of, if you're dealing with complex numbers, what we are targeting is j squared, because we know that j squared is a negative 1. All right, we understand that j squared is equal to minus 1. So we try by all means to expand in terms of what? In terms of j squared. So if we are to consider 16, it's direct, this one, because it can be given as j squared to the exponent of 8. Okay, 16 divided by 2 is a direct 8. Okay, so this one is just direct. Minus 9, but if you do that on 3, if you try now to divide 3 divided by 2, we are not going to obtain an exact value. So it means we are going to write this as minus 9j squared. So how are we going to obtain j to the exponent of 3? We must multiply by a j. Okay, so that it gives us j to the exponent of 3. What we want is to have j squared first. Then whatever follows, it follows. But once we have a j squared, is fine, because we know that j squared represents what? Minus 1. So here we are going to have 2 into negative 1 squared, negative 1 to the exponent of 8. And we know that negative 1 to the exponent of an even number is a positive. So it's going to be 2 times 1 minus j squared. Remember, it's -1, so it's negative, so it's going to be positive 9 j in that case. So this was going to be 2 plus 9j at the end. Okay, so this cannot be simplified further. And on this one, we are not told on 2.3, we just simplify. We're not told to leave our answer in rectangular or polar, just leave in polar. 2 marks for 2 marks is enough for us to leave in polar form. All right. So 2.4, this was just a mistake in the typing and so forth, but this is 2.4, which is supposed to start here, 2.4. And also, if you check on this 2.4, there was no question, it was just 2.4. So you did not know what is the question asking you to do. It was just 2.4 like that. All right. So, but for us, we are not gonna just leave, we're just gonna solve it for the interest, for the sake of revisions and so forth. What we are going to do is to solve for x, y, and z, okay? We are going to solve for x, y, and z. Okay. How can we solve for x, y, and z? We talked about this, guys, using our determinants. If you watch the video on determinants, that has got everything about our determinants. Okay, anyways, this is not the right time to talk about that. Let's see. Remember, from our determinants, if you are to see the way they wrote this, it's 1 over x, 4 over x, 3 over x. This is just the same as we are writing 1 times 1 over x like this, plus 2 times 1 over y like that. So we take not our values as x, y, and z, but we're going to take them as 1 over x, 1 over y, 1 over z, 1 over this. So meaning to say, we are referring just like we are calculating 1 over z first. I want you to understand what I'm trying to say here. It's like we are calculating 1 over x. If you find out that 1 over x is equal to 1 over 3, you can calculate x, you can just cross multiply x is equal to what? To 3. So you are going to calculate 1 over x. So meaning to say, you must have 1 over x, which is taken from the determinant of 1 over x over the determinant of the constants. To find 1 over y, it is going to be the determinant of 1 over y over the determinant with respect to constants. The same thing, 1 over z, the determinant of 1 over z over the determinant of what? Of the constants. All right, so let's start with the x. How do you calculate by the determinants? How are you gonna, by our Cramer's rule, how are we going to determine the determinant with respect to 1 over x? All right, so the determinant with respect to 1 over x, remember, guys, what I told you is that you are going to substitute, all right, in place of where that 1 over x is here, you are going to replace this part with the constants. The constants, these are the constants here, which is we are going to replace with 1 over 2, 2 over 3. All right, let us just try to put so that we can be able to write everything. So this is 1 over 2, 2 over 3, 1 over 3. Okay, you replace in where there is 1 over x. The part of 1 over y, it remains as it is with 2, 2, and minus 4. You take the number and the sign. So this will be 2, this will be 2, and this will be minus 4. For z, you take as it is plus 1z. This is 1. Z here, which is negative 3. Z here, which is a plus 4. You determine your determinant in this case, all right? You do the same thing if you are to calculate the determinant for that part of y. You are going to close this time. You are closing the part of what? The part of y in this case. You replace with the constants. So this is the part of y here. You're going to replace this part with the constants. So meaning to say the x is going to remain as it is. We're going to take the numbers as they are. This is 1, 4, and this is 3. All right, then the part of y, this one is the one that you substitute with the constants, which means we are going to substitute with 1 over 2, 2 over 3. This is 1 over 3, okay? Then the part of z is not affected because we are focusing with y, so the z remains as it is. This is 1 minus 3 and so forth. So it's going to be 1 minus 3 and 4, okay? All right, then we do the same thing for the determinant. with respect to 1 over z, all right? So the determinant with respect to 1 over z, in this case, we're going to have the same thing, which is going to be this time, we have to close the part of z. We substitute with what? The part of z with the constants, this part of z here. So x is going to remain as it is. Y also is going to remain as it is. So meaning to say x, we're going to have 1, 4. So that'll be 1, 4, 3. All right, the part of y, we have got positive 2, positive 2 again, negative 4. All right, then the part of 1 over z is the one that you substitute with what? With the constants, which is going to substitute with 1 over 2, 2 over 3, 1 over 3, like that, okay? Then the last one is for the constants. All right, so you can just have for the constants in this case. So the determinant that is going to affect our constants in this case. So for the constants, there's nothing that we are going to substitute in this case. We are not substituting anything because the constants are this side, there's nothing, all right? So we're going to take the part of x as it is, 1, 4, 3. So you're going to take the part of x as it is, that's 1, 4, 3. All right, the part of y also as it is, which is 2, 2, minus 4. This part of y as it is 2, 2, minus 4. All right, so you're going to have 2, 2 minus 4. So that's 2, 2 minus 4 in this case, all right? The part of z also as it is, the part of z which is 1 minus 3, positive 4, 1 minus 3, 4, all right? So that's 1 minus 3, 4 in that manner, okay? So you're going to have 1 minus 3, 4, all right? So this is what we just needed here. All right, so you're going to find our determinants corresponding to each, all right, the one for x, for y, for z, for the constants. All right, so let's start with the one for x. So we know that in order for us to have our determinants, we are supposed to use our signs, plus, minus, and so on. All right, so always I'm just going to use the first row, this one, plus, minus, plus. So I'm just going to take plus, minus, plus. All right, plus, minus, plus. So meaning to say here, I'm going to have the determinant with respect to x, 1 over x, sorry, which is going to be given as a half. Remember, we have chosen to work with this row, all right? So half is going to be affected by what? By a plus. The sign here is a plus. So it's going to be a half into, remember what you do is that you're supposed to close the row and column where that half is. So if you close also this column here, you're going to be left with 2 minus 3. They said that you take as it is. So this will be 2 minus 3 minus 4 and 4. All right. 2 affected by what? By a negative. So it's going to be minus 2. We find its determinant by closing the row and column where there is a 2. All right. So you're going to be left with these numbers. So that's 2 over 3. 2 over 3 minus 3. 2 over 3 minus 3, 1 over 3, 4. All right, then we move on to 1 affected by a plus. So it's just a plus 1. Find its determinant. So we close also this part where there is 1. So you're going to be left with 2 over 3, a 2, 1 over 3, minus 4. All right, so this is what you're going to have. So let's just find our determinant with respect to x. So just need a calculator on this part. Let's save our calculator and see. So on our calculator here, remember our determinant, like I said, you're going to multiply these numbers in the major diagonal. You multiply them together. You subtract from these two. You multiply these numbers together. You subtract. So it's like that, all right? So meaning to say on the first one, it was going to be a half, 1 over 2 like this outside of the bracket. Open the bracket, then multiply 2 times 4. So open a bracket for 2 times 4 like this. All right, 2 times 4, open a bracket for that, okay? Minus the product of these two, negative 3 and negative 4. So it's negative 3 times negative 4 together. Close that bracket and close the first bracket. You are going to obtain a negative 2 in that case from this part. So this will be a negative 2. You do the same thing on this part, negative 2 times the other part, you combine it together. So that's negative 2 into open 2 brackets for the product of 2 over 3 and 4. So it's 2 over 3 multiplied by 4 minus the product of negative 3 and a third. So negative 3 times a third, which is 1 over 3. Close the first bracket and the second one. This is going to give us negative 22 over 3, negative 22 over 3. The same on this part, if you calculate properly, you're going to obtain negative 10 over 3. Then you combine everything in this case. This will be the determinant with respect to 1 over x, which is going to give you negative 38 over what? Over 3. All right, let's just leave it like that, okay? This is the determinant with respect to 1 over x, not x, but 1 over x, okay? So like I said, let's just leave it like that, okay? Gonna also calculate for 1 over y. So the determinant with respect to 1 over y, just like the previous case, we're gonna use the same signs, plus, minus, and so on. So I'm just going to use the first row also, plus, minus, plus. So this is going to be plus 1. The first one here, it's a 1. So it's going to be plus 1. All right. Sorry for that. So this is going to be plus 1 here into the determinant of, we close the column also where there is this 1 here. So you're going to be left with this part. All right. So this is the one that you're going to remain with. 2 over 3 minus 3, 1 over 3, and 4, which is this part here. Okay. For minus, for half, we multiply by a minus, so it's going to be minus half. You close already, the row is closed, so you can just close the column. This one, you remain with 4 minus 3, 3, 4. Okay, so that's 4 here, minus 3, 3, and 4. Okay, then for 1, it's affected by a plus, so it's going to be plus 1. The determinant of, you already the row is closed, so you're just going to close the column. You remain with here 4, 2 over 3, 3, 1 over 3. All right, so that's it. You are going to determine the determinant of y. So just like what we saw, you're going to multiply the major diagonal, these two numbers, you subtract the product of these two, you multiply these two numbers. So you combine everything at once. You combine everything after doing this. This is going to give you the determinant of 1 over y, which is going to give you 9,5, all right? So you're going to have 9,5. Okay, we do the same thing for the 1 for z. For 1 over z here, you're going to do the same thing. The determinant with respect to 1 over z, that's going to be again plus, minus, plus. Okay, so this is going to be plus. So I'm going to take the first row here. All right, so that will be a plus 1. A plus 1 into the determinant. If we close already, the row is closed, you're going to close the column. So you remain with 2, 2 over 3 minus 4, and this is what you're going to remain with at the end. So that's 2, 2 over 3 minus 4, 1 over 3. All right, this is 1 over 3 here, 1 over 3. Okay, then we move on to 2 affected by what? A negative. So this will be negative 2 into the determinant of, we close the column also where there's 2, so you're going to remain with 4, 2 over 3, 3, 1 over 3. All right, so that will be 4 in this case, 2 over 3, 3, and 1 over 3. All right, like this. Then the last one, a half in the positive, taken here as a positive. So it's going to be positive half. Close the column and row. You're going to be left with what? 4, 2, 3, and minus 4. Again, you do the same thing. The product of this major diagonal, you multiply the numbers that are in this major diagonal. minus these two. All right, the same thing, whatever that you get, you must be able now to multiply with the number that is outside. Then you combine everything up to the what? Up to the final one, you combine everything. This was going to give you the determinant with respect to 1 over z, which was going to be negative 19 over 3. This was going to give you negative 19 over 3. So I want you to try it and do. You're going to get a negative 19 over 3 for that one. All right, so I think we have the one for x, for y, for z. You are now left with the constants. So for the constants, you are also going to do the same thing for your constants in this case. All right, so we're just going to have the same scenario, plus, minus, plus, as I'm using the first row in that case. Okay, so it's going to be plus, minus, plus. So meaning to say our determinant is going to be plus 1. All right, so it's going to be plus 1. The determinant of, we close the part of 1, we move on to minus 2, we close the part of what? Of minus 2, then plus 1, we close the part of plus 1. All right, so let us start with this plus 1 here. If we close this, what are you going to remain with? We are going to remain with this part here, all right, which is 2. You're going to remain with 2, minus 3, minus 4, 4. All right, we move on to minus 2. If we close the part of this 2 here, we are going to be left with 4, minus 3, 3, 4. All right, so that's 4, minus 3, 3, and 4. The part of 1, if you close it, going to remain with 4, 2, 3, minus 4. So that's 4, 2, 3, minus 4. You determine your determinant, just like what we have been doing in the previous case. The product of this major diagonal on your calculator minus that one, just like what we've been doing, you calculate your determinant. This was going to give you a negative 76 if you combine everything at once. Okay, now that we have these determinants, the one for 1 over x, 1 over z, remember our formula was that 1 over x is equal to the determinant of 1 over x over the determinant of what? The constants and so forth. So we are going to use the same scenario or the same formula that we have there to say, in order for us to have x, we are going to take it from 1 over x. Since 1 over x is equal to the determinant with respect to 1 over x over the determinant of the constant, we are going to have it as 1 over x is equal to the determinant with respect to 1 over x, which is negative 38 over 3, like this, divided by d, which is the determinant of the constants, which is negative 76, like this. All right, so this will be 1 over x is equal to, you can just try to simplify it on our calculator here. Just open a bracket, negative 38 over 3, close the bracket, divided by negative 76, like this. This gives us 1 over 6. So we're going to have 1 over 6. So to find x, we can cross multiply. All right, so you can cross multiply x times 1, which is x, is equal to 1 times 6, which is 6. So now we have the exact value of what? The exact value of x. So with the same idea, we can also find the value of y from there. For y, we are saying 1 over y is going to be the determinant with respect to 1 over y. Instead of 1 over x, is going to be this one. For 1 over y, which is minus 9,5 over the determinant of the constants, and our constants is minus 76. That's our constant. So that's 1 over y is equal to, so let's see what we obtain from our calculator in that manner. Okay, so if we are to simplify this, that's negative 9,5, all right, negative 9,5 divided by negative 76, like this, which will give us 1 over 8. So this is 1 over 8. So how now am I going to find the value of y? We can just cross multiply by 8 by y here. So it's y times 1, which is y is equal to 8 times 1, which is 8. So this we are obtaining exactly the value of y, which is y is equal to 8. All right, we do the same thing for z, all right? To determine our z, we're going to take it from 1 over z from our formula. We said 1 over z is going to be the determinant with respect to 1 over z, which is the one that we got of negative 19 over 3 divided to the determinant of the constants, which is negative 76. So that's 1 over z is going to give us what? So let's have our calculator. So we're just going to divide these two, open a bracket, negative 19 over 3, negative 19 over 3 like this, all right, divided to negative 76 like this. All right, this is going to give us 1 over 12. So we've got 1 over 12, then we can just cross multiply. So that's we can have the value of z, all right? So z times 1, that's as z is equal to 1 times 12, which is a 12. So meaning to say our z at the end was going to be a 12. So x was a 6, y being 8, and z being a 12 in that case. Okay, so as you can see, that was our question in this case, all right? That was our question on 2.4, all right? So as you can see, everything there being actually 7 marks, and the whole of this question 2, 20 marks. So this question 2, you can just see that it was just a combination of our complex numbers, the determinants also, all right, the application of our determinants, and which is actually fine. So I don't know for this question what's going to happen, because yet there was no question for this 2.4, there was no question. So it's either it is just going to be awarded the 7 marks since there is no question about this. Here I'm just answering something to say, let's say the question was asking us to calculate for x, y, and z, like what they mostly do. What were you going to do? But in this case, it was just they just typed, but not the question is not given. So I don't know, like I said, what's their final say about this thing. All right, let's see the other part of the question, which is now question 4. Question 3. All right, so this is question 3, which was a trig. This was trigonometry. All right, simplify this. All right, we asked to simplify. There is 4 marks for that. Okay, so let us just try and check our trigonometric expression that we are given. So this is sec squared. All right, so that is 3.1, whereby we are given sec squared of theta minus tan squared theta. So this is minus tan squared theta, everything over 1 minus cos squared. All right, so this is everything over 1 minus cos squared, 360 degrees minus theta. All right, so this is 360 degrees minus theta, like this. All right, so if we are to consider this part, let us just see what we have here. If we are to consider the first thing, sec squared minus tan squared, we're having a combination of an identity there. Remember, we have got 1 plus tan squared, all right? 1 plus tan squared of theta, 1 plus tan squared of theta, which is equal to sec squared. We know that this is equal to what? To sec squared of theta. So it's either you are to remove sec squared, replace with the part of 1 plus tan squared, or you are to remove tan squared, then you take this one this side so that it will be sec squared minus 1. It was up to you how to simplify this. But as you can see, it was going to be easier for us to remove this sec squared theta and substitute with what? 1 plus tan squared, because we can see that sec squared theta is equal to 1 plus tan squared. So this was going to be given as, in place of sec squared, we're going to have 1 plus tan squared theta, but already there is a minus tan squared theta that we have. So we're going to have tan squared theta. Okay, everything over. So if you are to check now, in the denominator, we are given 1 minus cos squared, 360 minus theta. All right, if we are to consider back our quadrants, all right, 360 degrees minus theta, we know that is in the fourth quadrant. And from the cast concept, in the fourth quadrant, cos there is a positive. So it means the cosine of 360 degrees minus theta is equal to the cos of theta. This is what we know. This is equal to the cos of what? To the cos of theta. So if this is equal to the cos of theta and yet given as cos squared, it means we are simply going to have this as minus cos squared, because we are supposed to have cos theta. For this 360 degrees minus, it gives us cos theta, but it's a squared. So if this is squared, it means also this is going to be squared. So it's going to be 1 minus cos squared theta. All right. Now let's see what we can do from here. On the numerator, we've got something common that we can consider tan squared minus tan squared. All right, that's a 0. You're subtracting 1 minus 1, so you're going to obtain a 0. So that's going to remain with 1 over 1 minus cos squared theta. Remember, from our Pythagorean identity, we know that the cos squared of theta plus the sine squared of theta is equal to 1. So to have 1 minus cos squared, it means this cos was transferred this side. So we remained with what? With the sine squared theta. So it is the sine squared of theta, which is equal to what? 1 minus cos squared theta. We're just transposing the cos theta this side. It becomes what? A negative. So it means wherever we are seeing 1 minus cos squared theta, we are also looking, or we are also having the same thing as sine squared theta. So we are going to substitute this as sine squared theta. So this is going to be sine squared theta like that. Okay. And we know that 1 over sine is a cosec, all right? So if 1 over sine is a cosec, this is 1 over sine squared. So it is going to be what? Cosec squared theta, cosec squared theta. Okay. So that is how you're supposed to have this question, okay? Then the other part on item 3.2, it was again another question that needed you to be very careful in your simplification. In which manner? In the sense of the idea that we are given, the information that we are given here, that 2 cos b minus 1 is equal to 0. It's something that gives us a certain part to work with. We are supposed to work with that. And not only that, and also the sign of the same b that we are talking about is less than 0. Meaning to say, the sign of b, if it is less than 0, it means we are talking about sign being a negative. That is what they are trying to say. Let's work with these two conditions. Before we talk about this question here that we are given, let's just talk about these two conditions. All right, that's 3.2. Okay, 3.2. So we are given that 2 cos of b minus 1, 2 cos b minus 1 is equal to 0, and also that the sign of b is less than 0. Less than 0, like I said, it means it is what? A negative. Values that are less than 0, these are negative values, -1, -2. Greater than 0, it means it's a positive. So, okay, what about here? What is it that we are going to obtain? This here, if we are to cross-check it properly, it gives us a ratio of cos. If we take this -1 to the other side, it becomes a positive. So that means we're going to have 2 cos of b, which is equal to +1. So to find cos b, just going to divide by 2 both sides, meaning say the cos of b is going to give us 1/2, which is a ratio, and it's a positive. We are having our ratio for cos being positive, and this ratio is going to give us the triangle. Remember, from the ratios, our mnemonics of our SOHCAHTOA concept, we shall use that part of our SOHCAHTOA concept now to determine or to have what? To have the corresponding ratio for this cos that we are having here. But for the meantime, we want where this cos is being a positive and the sign is being what? And the sign is being a negative. Which quadrant is it that we are supposed to consider where cos is a negative and sine is a positive? So let us take from our cast concept, or we're going to consider all students take calculus or cast like this, that is cast. Okay, which of the quadrants do we see cos being a positive? Okay, and sine being a negative. In the first quadrant, both they are positive. In the fourth quadrant, this is the quadrant for cos. If cos is positive here, it means sine is negative. This one is for sine. The second quadrant is for sine. Here it's sine, which is positive. Cos is negative there. But we want a condition which satisfies these two conditions. Cos, sine to be negative because it's less than 0, a negative, and cos to be positive. That was the fourth quadrant. So meaning to say you were supposed to have your triangle in the fourth quadrant like this. All right, this is what you were supposed to have. You're supposed to have your triangle in the fourth quadrant, and it's a right angle triangle that you're gonna have. And B being the angle that you take from the positive horizontal axis up to this line. This is the angle B they are talking about. Yes, when you are calculating, you're going to be using the angle that is inside of the triangle, but the angle they are talking about here is this B, this one, all right? So now, according to cos, like I said, from these trigonometric ratios, cos is adjacent over the hypotenuse. So we put adjacent here, and we also have the hypotenuse. According to this angle, this is our adjacent, which is this side, is our adjacent, which is 1, and our hypotenuse here, which is 2. All right, so we are going to find the third side, which is a negative because it's down. Remember, these are the x values. These are the y values. The y values are negative this side. The x values are positive. That's why we see this is a positive. Okay, the hypotenuse is always a positive. So as we can see, the question that follows, in order for us to have whatever these ratios that we are asked, we are going to also need the third side. So that's why we are supposed to work out this third side from our Pythagoras theorem. We can calculate the third side. Remember that the hypotenuse squared, which is 2 squared, is equal to x squared, which is 1 squared plus y squared in this case, which is the side that we want to calculate. So that's 2 squared, which is 4, is equal to 1 squared, which is 1 plus y squared. Take the 1 to the other side, it gives us a negative. So that will be 4 minus 1, which is 3, is equal to y squared. So determine the square root. So that means y was going to be plus or minus the square root of 3. So like I said, this, because it's down, it's below the x-axis, so it's a negative. The values of y down here are negative, so it's going to be minus the square root of 3. If it was on top, it was going to be positive square root of 3. All right, but down it's a negative. Okay, so this is what we're going to do to find the side and so forth. Now let us take our question. We have all the sides according to this angle, which is our B. We're going to use the angle inside. So we saw that this is our opposite. This is our adjacent, and this is our hypotenuse in that case. So let us try to answer our question. Calculate cot B plus cosec B over tan B plus cot B. Okay, that is our question, 5 marks for that. Okay, let us just write our question here. So the question needs us to determine the value of cot B. All right, so this is cot B plus cosec B. All right, cot B plus cosec B, everything over tan B. So we are given the tan of B plus the cot of B. Okay. Let us try to simplify by substituting here what we are given. Okay, let us simplify and substitute what we are given. Okay, the cot of B means 1 over tan. Okay, cot is the reciprocal of tan. You know that. We talked about this. So cot is the reciprocal of tan, meaning to say you're talking about 1 over tan of what? 1 over tan of B. But if we are talking about the reciprocal means 1 over, which is the tan of B is opposite over the adjacent. That is the tan of the opposite over adjacent. So the reciprocal is the opposite now. So it is going to be the adjacent. The moment you divide 1 over, so it's going to be the adjacent on top over the opposite. So this is the ratio for cot, 1 over tan. You interchange the ratio for tan. It was supposed to be opposite over adjacent. You interchange. That's the reciprocal of what? Of a tan, which is cot. So meaning to say our cot B, in this case, according to this, we said adjacent over the hypotenuse, over the opposite. Our adjacent in this case is 1. That is our adjacent. We are given 1. The opposite, which is negative square root of 3. So it was supposed to be 1 over negative square root of 3. But as we know that the negative, we have to write it on top. So we are going to just write it as negative 1 over the square root of 3, okay? Adjacent over the what? The opposite, 1 over minus square root of 3. All right, plus cosec of B. Cosec, same as what we did on cot. We are going to say that the cosec, in our actual sense, the cosec of B is supposed to be 1 over the sine of B. 1 over sine, cosec. But what is sine? Sine is opposite over the hypotenuse. So the reciprocal of opposite over hypotenuse, 1 over this is the reciprocal. So it's going to be hypotenuse over the opposite. So we simply need the hypotenuse in this case over the what? Over the opposite, which is the reciprocal of sine B. Our hypotenuse is 2 in this case, all right, over the opposite, which is minus square root of 3. So we are back again to that condition of a negative. So we're going to write the negative on top. So we're going to have minus 2 square root of 3 like this, okay? Everything over tan of B. Tan of B, we are taking straight opposite over the adjacent. So the opposite, which is minus the square root of 3 over the adjacent, which is 1, plus the cot of B. We talked about the cot of B before. We said it's going to give us minus 1 over the square root of 3 like this. Okay, so this is what you're going to have. This is a single part, all right, that you must consider, which is fine, or you can just consider this plus or minus A to give us a single term, which is a minus, all right, a single sign that we are going to work with, all right. So let us see what we can do from this part here. Let's say, okay, sorry for that. Let's say we want to separate these. All right, let's say we want to separate our solutions here. We want to separate like the denominator and the numerator part, work the numerator separately, the denominator separately. All right. On the numerator, we have the advantage of the denominators which are the same. That's our advantage there. So we can combine the numerators. Remember what I said, if the denominators are the same, just add your numerators or just combine the numerators as they are. So it's going to be minus 1 plus minus 2, which is something like minus 3. So we're going to have minus 3 over the square root of 3. Divided 2. That's why I'm saying we have to separate so that we see our numerator and we see our denominator separately. Okay. On the numerator, this is what we got. What about the denominator now? If we are to combine the denominator here, we are actually supposed to add. We are actually supposed to add this. Okay. So how do we add? Knowing that if we can have a condition that the denominators are the same, just like this part, what we had to say, if the denominators are the same, we can simply combine our numerators. We can do that because here there's a 3, there's a square root of 3, here there's a 1. How can I have a square root of 3 so that I have the same denominators here? I'm going to multiply by the square root of 3 over the square root of 3. So by doing this, it means this part that I'm having here in my denominator here, this part that I'm having in the denominator, it is going to be given as the square root of 3 times minus the square root of 3, which is minus 3. So it's going to be something like a negative. Let me just write it aside. Minus 3 like this over the square root of 3 times 1, which is the square root of 3, because we want us to have the square root of 3, just like this part. But this part, there's nothing that we're just going to remain with minus 1 over the square root of 3. Remember, what we wanted is for us to have the square root of 3 this side, so that the denominators are the same. So what we simply do was to multiply by square root of 3 over the square root of 3. Once the denominators are the same like this, we are now back to the same condition, just like the previous case, that if the denominators are the same, just combine your numerators together. So you're just combining your numerators together, minus 1, minus 3. Now, minus 3, minus 1. So if you combine minus 3, minus 1, we get minus 4. So it is going to be minus 4 over the square root of 3, which is the common denominator that made us to combine these two. Everything is going to be over the square root of what? Over the square root of 3. That's it. So, but on the simplification, the way you simplify, there are so many ways. Yeah, I'm just teaching you now new ways of answering these questions, because we've been talking about old ways. Now you need to learn at least new ways of answering. Okay, so anyways, but it's just one and the same thing. So here, to remove our division, and we are going to introduce a multiplication. So it will be minus 3 over the square root of 3. Then the moment we introduce our multiplication, what happens is that we're going to invert, just tip the second fraction. So the square root of 3 is going to be on top. So we are going to have the square root of 3 over a negative 4 like this. We interchange, all right? So this is going to give us 3 over 4, because definitely this will cancel and this will cancel. We remain with 3 over 4 in that case, okay? So at the end, this is just going to give us a 3 over 4. All right, I think that's what we have in this case. All right, 3 over 4. I just wanted to confirm also something here, minus, all right, 3. I think, yeah, I think that's it. I think that's it. We can also prove this. All right, let's just simplify like on our calculator direct and see if we're gonna get 3 over 4, okay? Let's just do this on our calculator here. We're just gonna simplify this stage. We've got a fraction. So we've got negative 1 over 3, negative 1 over the square root of 3, sorry, the square root of 3 like this. Then we have got plus, minus, which is a minus. We're gonna have minus 2 over the square root of 3. So this is 2 over the square root of 3, all right? 2 over the square root of 3. Then we move on to the denominator. We've got minus the square root of 3. So that's minus square root of 3 in that case, all right? Plus, plus and minus gives us a minus. So it's going to be minus 1 over square root of 3. So it's going to be minus 1 over the square root of 3, all right? So this is going to be a 1 here over the square root of a 3. All right, so let's have it this way. So you can just use your calculator to prove this, and this, it gives us an error is the square root of 3 minus. All right, I don't know what do they want us to do here, to just have a bracket. All right, let's just try and have a bracket of everything. Maybe now our calculator is confused with a lot of things. I'm just gonna put a bracket here. Let me remove this bracket, close it here. Our calculator now is confused. There are a lot of fractions. a lot of fractions, a lot of this and that. But anyways, let us try to assist our calculator. We're gonna put a bracket there. All right, here. No. So my calculator, I don't know why is it that slow. I don't know what's happening with this software, guys. But it's supposed to give me a bracket here. Okay, just sorry for this, guys. Still, I don't know how did I put this negative square root of 3. Negative square root of 3. Guys, my calculator is just somehow misbehaving, guys. So, just hope you can do that. Okay, so guys, we can waste much of our time here. I just want you to do that on your calculator and see what you're going to get, but it's supposed to be exactly this 3/4 there. So it's just, I don't know, guys, what is happening with this thing. It's just, I don't know. But if you can see, that is what you're supposed to have, which is a 3/4 in that manner. So it can be like that, you know, these softwares, what they do, these softwares, sometimes they just misbehave. All right, anyways, let's hope it's not gonna misbehave because we need to finish this paper. All right, on question number 3.3, it was to prove the identity, prove the following identity. All right, so remember, to prove is in your hands. A proof type of a question is actually in your hands. What am I trying to say if I'm saying it's in your hands? You have to work it in the way that you understand. Okay, pick the most complicated side like this. The right-hand side was gonna be the best side to work with. All right, so let's just try 3.3. Let us just try to prove here. All right, let's see what you're gonna have. Just gonna change. So on 3.3, we are asked to prove that the sec of 2a plus tan 2a plus tan of 2a must be equal to the sine of a. So if for the sine of a plus the cos of a, everything over the cos of a. And it looks like we did this type of a question during our revisions, but I don't know, maybe. But I still remember talking about this type of a question. Okay, anyways, let's see. Like I said, it was going to be easier if we work with a complicated side, like we are trying to simplify it and see if we can simplify this to be like that part of the left-hand side. So as for me, it was gonna be best to work with the right-hand side, in that case. Okay, so let's work from our right-hand side. From our right-hand side, we've got the sine of a, the sine of a plus the cosine of a, everything over the cosine of a minus the sine of a. This is what we have. I talked about a question of this nature, and I still remember where I said, this one, it needs you to relate with your identities. Remember, if you're dealing with identities, you must have that foresight of what is to come. If you check here, there's a difference of 2 squares that can be formulated in our denominator here. That can be formulated. How can that be formulated? If we multiply by introducing a negative here, we multiply by the cosine of a plus the sine of a, in this case, the numerator, which is the sine of a. Then our denominator with the same thing, which is the cosine of a plus the sine of a. So we're going to have the cosine of a plus the sine of a. We are having a difference of 2 squares that is being formulated there. We've got a negative, we've got a positive there. We are having a difference of 2 squares if you take it properly, from a squared minus b squared. So that means at the end, we are having a product that is going to happen on the numerator, where this here, sine a plus cos a, and here it's cos a plus sine a. Sine a plus cos a is not different from cos a plus sine A, just like A plus B. It's same as B plus A. So if I write sine A cos A plus cos A, it's the same, cos A plus sine A, okay, which is going to multiply cos A sine A. But if I'm multiplying cos A by sine A by cos A plus sine A, it means what? It means I'm just going to raise this to the exponent of what? To the exponent of 2. Or you just save your two brackets, it's fine. Just save your two brackets, you expand them, it's one and the same thing. So like I said, in the denominator here, this is a difference of two squares that we are seeing. So it was taken from what? From cos squared of A minus sine squared of A. Remember our A squared minus B squared. A squared minus B squared is equal to A minus B into A plus B. So the order here does not matter, right? But what matters is that we can see that these two brackets is the same. Cos A, sine A minus plus. So it was taken from A squared minus B squared from our difference. We just square these terms, just gonna square the cos and the cos. You square the sine and the sine, but having a negative there. All right, so if you expand cos theta, which is cos A plus sine A squared, this is going to give us what? The cos squared of A plus, remember our identity, it is going to be 2 cos of A, the sine of what? The sine of A plus sine squared A. All right, so which identity am I talking about? Am I saying remember the identity? Remember from our N3, we talked about A plus B squared, which is equal to A squared plus 2AB plus B squared. That is the first term squared plus 2 times first and last plus the last term squared. Okay, so this is what we have. But from the denominator here, there's something that you can see. Cos squared A minus sine squared. If you check this, this is an identity that we know, this one, from our double angle identities. Cos squared minus sine squared is equal to cos 2A. Remember that identity the double identity for cos. So this is equal to cos 2A. Remember, cos 2A is equal to cos squared A minus sine squared A. Or it is equal to 2 cos squared A minus 1, or it is equal to 1 minus 2 sine squared A. There are so many identities for cos 2A. So this one is equal to cos 2A. And also, if we are to check from the numerator, there are some identities that we can see here. Cos squared A plus sine squared A. We know that cos squared plus sine squared A is equal to 1. So this is going to give us a 1. So you're going to have 1 plus 2 cos A sine A. The way that we wrote it may be confusing, but this do not be confused because it is the same thing as that part 2 sine A cos A. This is the one that you are used to. And we know that 2 sine A cos A was taken from the sine of what? From the sine of 2A, from the double angle of sine. Sine 2A is equal to 2 sine A cos A, which is the same thing as what we have 2 cos A sine A. So meaning to say that whatever that we are having here can be replaced with the sine 2A. All right, so this is going to be plus sine 2A, everything over what? Over the cos of 2A. So as you can see, we are almost there because at least we are seeing these 2A that we have on our answer, because our answer, if you check, it's written in terms of 2A, sec 2A, tan 2A. So we are almost there. So how are we going to simplify from there? That is the question. How are we going to simplify? All right. Remember, if you are given a fraction like this, you can separate this. I talked about this a lot of times. If you still remember that a fraction of this nature can be separated as 1 over the cosine of 2A plus the sine of 2A over the cosine of 2A, the sine of 2A over the cos of 2A. Okay, so let's simplify 1 over cos. What is the answer for 1 over cos? Remember, 1 over cos, it's sec. So if it is 1 over cos 2A, it is going to be sec 2A, okay? plus sine over cos. We know that sine over cos is a tan. So if it is sine 2a over cos 2a like this, 2a and 2a, it must give us what? It must also give us tan 2a on our answer. And this is exactly what we were given on the left-hand side. Okay, so that is the proof part. So when you're dealing with questions to prove, you must write exactly, obtain exactly what you have on the other side. Yes, there are some questions that I explained in our videos for proving identities, that some of the questions might not be direct. You prove one side and you prove the other side, but this one, it is direct. What we proved from the other side of the equation is directly equal to what we have on the other side of what? On the other side of the equation. So that is it for this question. That is what we're supposed to have. And we also have on question 3, which is 3.4, that was a trigonometric equation. So for x in the following trig equation, and that is 6 marks for that. All right, so this is 3.4. All right, so you're taken from negative 360 up to positive 360. Take note of the interval from negative 360 up to positive 360. All right, so we are given the equation in this case, that is 2 sine. All right, so this is 3.4. So we are given 2 sine squared of x minus the sine of x minus 1 is equal to 0. And our interval is taken from negative 360 degrees to positive 360 degrees, which is our theta in this case. Okay. Which is our x in this case. Okay. This, if we are to consider, it's a quadratic equation that we have. Yes, we can play around with your factorization, but if you know that is going to be a difficult thing for you to test that to say it's factorized, no, just use a quadratic formula at once. All right, our quadratic formula states that x is equal to, so we're going to have it as the sine of x, but not x this time, it's sine of x. So it is going to be the sine of x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So this is what you're going to have. And our a being the first term, the coefficient of the first term. All right, then we move on to the sign, which is a negative sine x, which is there's a negative 1. This is our b, the constant, which is our c. So we can have this direct on our formula. The sine of x is going to be negative b, which is our b is a negative, so it's going to be negative 1 plus or minus the square root of b squared, which is negative 1 squared. So we're going to have negative 1 squared minus 4 times a. In this case, we're going to have minus 4a, which is 2. So that is 2 times, that is 4ac, our c, which is negative 1. In this case, everything over what? Everything over 2 times a, which is 2 times 2, like this. All right. So you are going to simplify this. You can use your calculator direct at once, or you can simplify stage by stage. It depends on your simplification. So in this case, our sine of x was going to be having 2 possible values. If you simplify properly, this was going to give you a 1, or the other sine of x was going to give us negative 0.5. So that's negative 0.5 on the other hand. All right, so remember our interval that we are taking our values from negative 360 to positive 360. That one you're supposed to consider it properly, because here what you're going to do is to find the reference angle. All right, so for sine, we're going to have our reference angle. But remember what I said, if sine is equal to 1, you can also consider the graph of what? The graph of a sine, but you can also consider the reference angle. Remember, the reference angle is arc sine or arc cos or arc tan of whatever that you have. Here we are dealing with a sine. So it is going to be arc sine of what? Arc sine of 1. So on your calculator, let's see, this is going to be arc sine of 1. That is a shift sine 1 like this. All right, shift sine 1. this is going to give us 90 degrees. Okay, so the reference angle is going to be 90 degrees. With the reference angle, now we can consider the angles that we need where sine is being what? Is being a positive. We know sine is positive in the first quadrant and in the second quadrant. But in the second quadrant, we know that the angle there is supposed to be 180 degrees minus theta, which is 90 degrees. So we are going to have the same angle of 90 degrees. So for one, our angle is going to be 90 degrees. But we can't see all of the angles. We can't determine all of the angles like that. You can also consider the graph of a sine. Remember, the graph of a sine, it gives us all the values, because remember, I take it from negative 360. So it means we remember the graph of sine is like this. We are used to from 0 to 360, but it's going now from negative until it goes to negative 360. So where it is equal to 1, we can see it happening at 90 degrees here. It is going to correspond to 1 at 90 degrees. And at the same time, at this point, which will be at negative 270 degrees. Remember, this is negative 90, negative 180, negative 270, negative 360. So at negative 270 degrees, also the graph of sine will be at 1. At 90 degrees, also the graph of sine will be equal to 1. So it means minus 270 degrees is part of what? It's part of our solution. So also our x can be negative 270 in this case. We are saying our x for this sine, it can be 90 degrees, or it can be also be minus 270 degrees. Okay, let's consider our sine to be a negative. We need the values of x if our sine is a negative. So the first thing is to determine the reference angle in that case, all right? So our reference angle, as I always say, that you do not consider the negative. The negative is now for the quadrant where sine is a negative. But for the reference angle, you just take the arc sine as it is. So it's arc sine of 0,5. That's your reference angle. So your reference angle in this case was going to give us 30 degrees. So where do we have our sine being a negative in this case? Okay, want the quadrant where sine is being a negative, all right? So from the cast concept, all right, we're gonna consider our cast sine is being a negative where we do not have s, okay? In the first quadrant, it's a positive. In this quadrant, it's also a positive. So meaning to say sine is negative here and is also negative here in the third and in the fourth quadrant. How do you find the exact angle in the third quadrant? Remember, in the third quadrant, you're gonna have 180 degrees plus the reference angle. You add the reference angle in the third quadrant, okay? So your x for positive angles, you're talking about x being a positive angle, all right? It is going to be 180 degrees plus the reference angle in this quadrant, which is gonna be 180 plus 30, which is something like 210 degrees. But remember, these are two angles that can be found in this quadrant. We've got a positive angle and we also have a negative angle. What about the negative angle, this one that we take in this direction? How are we going to find the negative angle? We are going to subtract, right? 210 this angle minus 360 because we are remaining with this angle. So it's going to be 210 minus 360. So x also can be equal to 210 degrees minus 360 degrees, which is going to give us negative 150 degrees. Remember, our interval is taken from negative 360. They said from negative 360 to positive 360. That's why each solution you have to consider also having a negative answer. You are not focusing only on positive answers like a positive angle. You must also consider having negative angles because you are talking about negative 360 there. All right, let's move on to the other quadrant. We were in the third quadrant. In the fourth quadrant, we're going to obtain our x also the same way. Remember, in the fourth quadrant, the exact angle, because we said our reference angle is 30, but sine is negative in the third and in the fourth. All right, so in the fourth quadrant, this is how you're going to have your angle is going to be 360 minus the reference angle. So meaning to say our x is going to be 360 degrees minus the reference angle, which is 30 degrees. So this is going to be what? 330 degrees, all right? Or the same x, because we're talking about negative angles. Remember, in the third quadrant, this is a negative angle. This is how you take the negative. This is, you just take this direction. So it's just minus the reference angle in terms of the negative. So it is going to be minus the reference angle, which is minus 30 degrees. So all these values that we see, all these angles that we see, all these answers, they satisfy the value of x. They satisfy, or they are giving us the same answer. If we substitute them into the equation, they are the values of x that we want. So therefore, we can conclude that our x was going to be equal to, the smallest one is going to be what? Negative 270. Negative 270, followed by negative 150. Okay, then we still have another negative. Yes, we've got negative 30. All right, negative 30 degrees, followed by the smaller one. Now is going to be 90, followed by 90 degrees. From 90 degrees, followed by 210 degrees, followed by 330 degrees. All right, so these were supposed to be our possible values of x in within the interval that we are given. Meaning to say, if we were given a certain interval, some of the values were not going to appear because of the interval that you are working with. So you work with the interval that you are given to work with. But as you can see, that was just a direct question. Also, you just needed to understand the idea of your reference angle and how to use your reference angle in practice. All right, question number 4. Determine the following limit on 4.1. We're given the limit. This one we can just play around with it here. Remember, we talked about the sine squared. This one can be something from our factorization, but we can't factorize. All right, remember the first thing when you're dealing with a limit is to try substitute a 0 here. So sine squared is going to be 0 over cos 0 is a 1, so it's going to be 1 minus 1, which is a 0. So it's going to be 0 over 0. And this does not exist in our limits, 0 over 0. So what are you going to do? It's either you're going to factorize, but these ones cannot be factorized. But if you check here, there's something that is hidden in this sine squared here. What is it that is hidden? We know that the cos squared of x plus the sine squared of x gives us a 1. So to have the sine squared, it means we are just transposing cos x to the other side. So it means that sine squared of x is equal to 1 minus cos squared of x, which is something that we can be able to factorize. So in place of sine squared x, we are going to substitute 1 minus cos squared x. So what it simply means is that here we are going to have our solution as, this is 4.1. The limit, all right, as x is still approaching to 0, x is still approaching to 0, but now in place of sine squared, we're going to have this as 1 minus cos squared of x. All right, everything over what? Over 1 minus cos x, everything over 1 minus cos x. What have we done? Are we not making things worse by doing this? No, we are not, because this can be factorized. 1 minus cos squared x is a difference of 2 squares that we see, because 1 is same as 1 squared. So it means we can be able to simplify this by factorizing our difference of 2 squares. This is going to be 1 minus cos. The square root of 1 is 1. The square root of cos squared is cos x. So it's going to be 1 minus cos x into a bracket of 1 plus cos of x, like this. All right, everything over what? 1 minus cos x. Everything over 1 minus cos x, like this. Okay, sorry for this. This is 1 plus cos x plus cos x, okay? So by simplifying, we are going to see that By factorizing, we are seeing the two brackets that are the same, 1 minus cos x, 1 minus cos x. So we're going to be left with 1 plus cos x in this bracket. So we're going to be left with the bracket of 1 plus cos x. Let's try our limits again. If x is approaching to 0, we are going to substitute a 0 there. So we are going to obtain cos 0 plus 1. What is the value of cos 0? Cos 0 is equal to 1. So 1 plus 1 is going to give us as 2. So this was going to give us a 2 at the end. Okay. So that was your limit. That was your limit. 4.2, expand 1 over this to the exponent of 5. All right. Okay, let's see. That's 4.2. So we are given 1 over x plus h. This is x plus h to the exponent of 5. So remember, we talked about the binomial expansion where I said it's best for you to write in a way that x starts and also x is in a way that is the one that we can be able to the one that we can be able to simplify properly. What am I trying to say? This can be given as x plus h like this to the exponent of -5. Remember, 1 over means to the negative. Okay. How do we apply our binomial? Yes, there's a normal formula that I talked about in the previous case, but remember what I said. If you consider binomial is just a differentiation which is happening. What am I trying to say? I told you guys, you take the first term, raise it to the exponent of the power that you're given, which is the first term. It starts with that power as it is, right? So it's going to be x to the exponent of -5. Okay. Then this is what I told you. I told you that you find the derivative of this. The derivative of this, you're going to add the derivative of this term. What is the derivative of this? We drop the exponent. So it's -5 x to the exponent. We subtract 1. The derivative, we're going to subtract a 1. So it's going to be -6. All right. Here it was h to the exponent of 0. That's why we did not write this h. But this h is going to increase now, h to the exponent of 1 over what? Over 1 factorial for this exponent 1. All right. So where there's x, you find derivative. Wherever there's x, you find the derivative. This is it, guys. You're going to enjoy this. I want you to see plus. Let's find the derivative. Where there's x, you're going to find the derivative of this. Find the derivative of this. So what is the derivative? You multiply -6 times 5, which is +30. And what do? We subtract 1 on the exponent. So it will be -7 like this. While h is increasing, there's no derivative on h. It's just increasing. It was 0. Now it's 1. It's going to be at what? At 2 and so on. But the exponent over that factorial. The same thing plus, we do the same thing, guys. As you can see, on x, we have to find the derivative on x. The derivative on x here, we're going to multiply. So it's 30 times -7. That is the derivative. So if you multiply 30 and -7, you obtain -210. What do? You subtract a 1. Remember the derivative, you multiply, then you subtract 1 on the exponent. So it's x to the exponent of -8. H is increasing. So it's now to the exponent of 3 over what? Over 3 factorial. Guys, this is not going to finish because it has or it carries a negative exponent. I talked about this. So it is going to continue and so on 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 and so on. So mostly you simplify up to 4 terms like this. We can be able to simplify everything properly. So remember, here just need us on our calculator. Just going to take our calculators here. So x to the exponent of -5, h to the exponent of 0 is 1. So this is just going to be 1 over x to the exponent of 5. All right, the same thing here. -5 divided by 1 factorial. it gives you minus 5. You can also do that, guys. This is your calculator. Let's just also have our calculator, but that is going to give you a negative 5, okay? If you divide negative 5 divided by 1 factorial, this is 1 factorial like this, which is going to just remain as what? Negative 5. So this will be negative 5h. H is having a positive, so it's h, but x is carrying a negative exponent. So you write it in the denominator. So that's x to the exponent of 6. The same thing, but you have to divide first. 30 divided by 2 factorial. So it's going to be 30 divided by 2 factorial like this, which is going to give us 15. So this will be plus 15. H is carrying a positive. H squared is a positive, but x, it's a negative. So you write it in the denominator as a positive, x to the exponent of a 7. The same thing, negative 210 divided by 3 factorial on the last part. So it's going to be negative 210 divided by 3 factorial. In this case like this is going to give us negative 35. So that is going to be negative 35h to the exponent of 3, which is a positive, over x to the exponent of 8 as a positive in the like that. So that is what you're going to have, and so on. So like I said, this one, it was not going to finish. You were going to expand as much as you can, expand and expand and expand and expand again and again and again. It was not going to finish. So that is, we just simplify up to 4 terms as per a requirement of our syllabus, and just leave it like that. Okay. Let's consider the other part. Use the first principles to differentiate. So this time they gave us to the exponent of 4, but it's not a surprise. Remember 2021, they gave us to the exponent of 5. So to me, it wasn't even a surprise to see this happening. But anyways, let us consider this. Use the first principles to differentiate this. 5 marks for that, but the marks there, they were just few marks, a little bit few. Okay, anyways, let's see 4.3. We are given y is equal to x to the exponent of 4 minus 3x plus 6. So this is actually our f of x. So we are having this as our f of x, which is equal to x to the exponent of 4 minus 3x plus what? Plus 6. Remember, from the first principles, we are using the first principles, and it states that the derivative of y with respect to x is supposed to give us the limit. We are now back to the limits as h is approaching to 0 this time, of f of x minus x. So this is going to be f of x plus h minus f of x. All right, everything over what? Everything over h. This is the formula that you are supposed to be actually using. All right. But we have to consider a lot of things on this formula, because of the exponent that you're having of 4, you're having a bigger exponent to consider. So on your f of x plus h, it means you are supposed to substitute, all right? You are supposed to substitute x plus h. So what I'm going to do is to simplify what we see on the formula. Then we just have to substitute our answer at the end. I'm going to work out everything separated. You are going to see it. It's I think I explained that in another video, and this is what I'm going to do. All right, let's just so I'm gonna do a proper line. I think this one is fine. Very sorry for that. But like I said, I'm just gonna work these things separate. We already have our f of x, so we need f of x plus h. Okay. F of x plus h means in place of x, we are going to substitute x plus h. Where there is x, we are going to put x plus h. So it is going to be x plus h like this, to the exponent of what? To the exponent of f4 minus 3 into x. X plus what? X plus h to the exponent of what? This is just x. We do not have like exponent of this, just exponent of 1. So it remains like that. Then the 6, there's nothing that we do not have x, so it's just going to remain as a plus 6 like that. So this is our f of x plus h. But as you can see, our f of x plus h, we are now back to that binomial again, because we've got an exponent of 4. In order for you to expand this, you are supposed to consider your binomial expansion. Remember what I said, the first term, raise it to the exponent that you see, which is what? Which is 4. So it is going to be x to the exponent of 4. While the last term will be at what? Will be at 0. And for 0, you do not write any 0 factorial, just leave it like that, okay? Then we move on to the second one, plus you find the derivative where there is x. Find the derivative there where there is x. What is the derivative of 4 of x to the exponent of 4? The derivative of x to the exponent of 4 is 4x to the exponent of 3. Okay, while h is increasing, so it's now h to the exponent of 1. We are not having h here, so we are now having h to the exponent of what? 1 over 1 factorial. All right, we move on. We are still expanding. Now we are at this term. Find the derivative. Wherever there's x, you find the derivative. So it's going to be plus the derivative of 4x to the exponent of 3 is going to be 3 times 4, which is 12. So that will be 12x to the exponent. We subtract 1, which is 2. H increases in terms of power. So it will be now 2 over 2 factorial plus the derivative, again, the derivative of 12x to the exponent of 2. 2 times 12, that is 24. So it's 24x, 2 minus 1, that is going to be a 1. H is increasing. So that's to the exponent of 3 over 3 factorial plus. The same thing here is now a 1. So you're going to have the derivative. So what is the derivative of 24x? Is just a 24 in this case, all right? So it's going to be 24 h to the exponent of 4 over what? Over 4 factorial. This is now actually x to the exponent of 0 because we're going to subtract a 1. So as you can see, x starts with 4, ends with a 0. H starts with a 0, it ends with what? With a 4. That is, here we are having a positive number. So it ends. It ends. This is our end point. As you can see, if we try to find the derivative of this, it's going to be 0, 0, 0, 0, and so on. So we have ended. Which is a different when you are given a fractional exponent and a negative exponent. That one is not going to end. You are going to expand, 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 expand it, and expand and expand and expand. So you work up to a certain terms. But this one, because it is a positive exponent, it has to end. So what were we doing here? We were expanding x plus h to the exponent of 4, this one. We were expanding this part here. But what about the rest here? We have to expand this part of -3 into x plus h. So it's -3 times x, or just rewrite as it is, or just expand -3 times x, which will be -3x, -3 times h, which is -3h plus 6. Just gonna write as it is. Okay, so now let's simplify, guys. H to the exponent of 0 is 1, so this is just gonna remain as x to the exponent of 4. We simplify here, this is going to give us plus 4x to the exponent of 3h. All right, if you divide 12 divided by 2 factorial, it was going to give us a 6, okay? 12 divided by 2 factorial, that was going to give you a 6, which is 6 x squared, h squared. 24 divided by 3 factorial, just like what we did, this one was going to give us a 4 in that case, all right? So that was going to give us a 4. So that's 4x h to the exponent of 3. 24 divided by factorial, factorial of 4, it is going to be 1. And x to the exponent of 0 is 1. So you're just going to remain with what? H to the exponent of 4. So that was going to be plus h to the exponent of 4 minus, this part remains as it is, minus 3x minus 3h plus 6. All right, so this is our f of x plus h. But as you can see now, we've got a lot of things to consider. And if we now try to bring this back and subtract, you see that you will have to consider a lot of things. So this is what I was saying. Instead of you bringing this back to your formula, this is what you're going to simply do. You are going to find f of x plus h here, because on your formula, there is f of x plus h minus f of x, where you are subtracting f of x. So you are simply going to find that. All right, so you're going to find f of x plus h minus f of x. What am I trying to say? This is our f of x plus h, this one. So what we are simply going to do is to subtract f of x, and our f of x, all right, sorry, our f of x is this function that you're having here. So it means to subtract this, x to the exponent of 4, the part of x and the part of 6 will cancel. That is what it means. So you are going to see that if you subtract that f of x here, this x to the exponent of 4 will cancel, the part of x of 3x and minus 3x will cancel, and also the constant 6 and minus 6 will cancel. So you're going to remain with this part representing your f of x plus h. This is what you're going to remain with. And as you can see there, h is common on your f of x minus h, because you're going to remain with this part. Like I said, those ones canceled. You're going to remain with this part, and also this 3h is there. But as you can see, h is common throughout, so you're going to factor out h. So you remain with 4x to the exponent of 3. Here, if you divide, you're going to remain with 6x squared h. And this one is going to give us 4x h squared. If we divide here, we're going to have h to the exponent of 3. If we divide by h, this will be a minus 3, because we are factoring out h, right? So this is our f of x plus h minus f of x. But on our formula, what is it that we want? We need f of x plus h minus f of x over h. So we are going to divide this by h now. So if we divide this by h, it means we're going to also divide this by h. We now have f of x plus h minus f of x over h. So this h and the h will cancel. So this is the part that you're going to remain with, this one. This is the one that I want us to take on our answer, this one. 4x to the exponent of 3, this and that, all right? So this is the one that we're going to take into this limit here, all right? So it means we are going to have our limit as, our derivative here. We're going to have our derivative as the derivative of y with respect to x is equal to the limit as h is approaching to 0 of this whole part, f of x of, we simplified everything. We now have this thing, this whole thing here. We now have it. This is the one that we simplified here. So we just substitute, we are just taking this as it is, which is 4x to the exponent of 3, this and that. Let me just try to minimize this one. This is it. This one as it is. We are now substituting in place of what? In place of this. So you're going to substitute as it is, which is 4x to the exponent of 3 plus 6x squared h. So this is 6x squared h. All right. Plus 4xh plus 4x h squared. All right. Unfortunately, guys, I'm just gonna remove this part. All right. Unfortunately, I wanted us to work this to see it up to the end, but unfortunately, there's no space. I'm just gonna remove this. All right. So here we're gonna have 4x h squared plus h cubed minus 3 like this. All right. So we have substituted our f of x plus h, this one, in place of our f of x plus h minus f of x. So that means we can now apply our limits, because this is what we wanted all in our simplification. This is what I said you can have, or you can work it in that manner. So at this stage, now we can apply our limits so that we can have the derivative of y with respect to x. So therefore, the derivative of y with respect to x is going to give us what? We're going to have the derivative of y with respect to x wherever there is h, we are going to substitute as 0. Wherever there is h, we are going to substitute what? As 0. So this gives us a 0, 0, 0, 0, 0, 0, and so forth. So we are going to be left with 4x to the exponent of 3. So this will be 4x to the exponent of 3 minus 3. All right, so that was going to be our answer at the end. And if we have to prove this, because these are derivatives, yes, that we are using our first principles, but we are supposed to prove that. If we prove here, the derivative of this multiply, that is going to be 12x to the exponent of 3. All right, 4, sorry, I'm now finding this one. Okay, so this is 1 times this, which is going to be 4, so it's 4x, we subtract 1, which is 3. Then minus 3x is going to give us minus 3, all right, which is the same thing. So as we can see, it is actually giving us the same thing, just like the previous case, So these are the typical questions that you might be given. In fact, that was the question that we actually had. So it is just a matter of you understanding your questions, understand your questions properly, how they are given. How are they given? You must understand your questions. All right. Anyways, let us see. The other part of the question, it was to differentiate. Remember this one, you have to differentiate each by 1, 1, 1. Differentiate this. That was 8 marks. Actually, this was a lot of things. Actually, if you consider, this was a lot of questions. All right, to 4.4, no problem. Let us try to simplify. Remember, I always say, before you differentiate, try to rearrange in simpler form. All right, so here, because of our time, I'm just gonna write it, the derivative of once, the derivative at once. So we have the derivative. All right, this is, all right, let me just try and minimize a little bit. So this is 4.4. All right, so like I said, I'm just gonna find the derivative of y with respect to x direct. I'm not gonna rearrange like I always do. All right, so let's start 1, 1, 1, 1. Can we find the derivative of 3 over 2 to the exponent of x? It's impossible because of how this 2 is written. All right, so meaning to say this, we can write it as a positive. We can take this negative exponent on top, we write it as a positive. So it's supposed to be 3 times 2 to the exponent of positive x. This is what we're supposed to have. Then we can determine the derivative now. How can we determine the derivative of this? Remember, for this type of a log, for this type of a exponent, I talked about this to say we can have the derivative with respect to x of k a to the exponent of f of x like this. All right, the derivative of such is going to be equal to k remains as k is the constant, remains as it is. You find the derivative of f of x. So it's going to be the first derivative of f of x, a to the exponent of f of x as it is, times the ln of a. Okay, this is how you find this derivative, okay? K to the exponent, k times the first derivative of x, a to the exponent of f of x, then the ln of a. Okay, so meaning to say here, if you consider that our k is the constant, which is 3. So we're gonna have this as 3. The derivative now of this is going to be 3. All right, the first derivative of our f of x, which is in this case, it's the 1x, there is just a 1. All right, a, this one remains as it is, guys, 2 to the exponent of x times the ln of a. Our a is the base, which is the 2, just like this part, a to the exponent of which is ln 2. So it was going to be 3 times 2 to the exponent of what? Of x. 3 times 2 to the exponent of x, ln 2. All right, so that's it, 3. So you're just gonna write it as here, the final answer for this one it was going to be 3 times 2 to the exponent of x ln of 2 like this. All right, ln of 2 like that. Okay, so that is it for this one. Let's move on to the other one. Like I said, we're going to find the derivative of each until we finish. I'm not going to erase this. We need this also on pi. This is pi over e to the exponent of 3x. So this, we can take it on top. So this one is a positive. So the moment we take it on top, it becomes a negative. This one was a negative. So it was negative. That's why it ended up as a positive, okay? So this one will be a negative. So it's going to be pi e to the exponent of minus 3x. So as you can see, we are back to the same scenario here, whereby our k is pi. So the derivative of this is going to be pi times the first derivative of f of x. The function of x is minus 3x. The derivative there is negative 3 times a to the exponent of f of x, which is this e as it is. So it's e to the exponent of minus 3x times the ln of a, which is the base, which is the ln of e. And we understand that the ln of e is equal to 1. So this was going to give us negative 3 pi e to the exponent of x, this one, because ln e is equal to what? Ln e is equal to 1. So the derivative of this whole part was going to be equal to negative 3 pi. So it's just going to be negative 3 pi e to the exponent of minus 3x like this. Okay, let's move on to another one. I don't think we're gonna need this e. We no longer have this. All right, so let's move on to another part. The other part, we have got minus cosec x here, minus 1 over cosec 3x. All right, so the first thing is 1 over cosec. What is it that we obtained? Remember, cosec, we obtained it from sine. All right, cosec, we obtained it from what? From 1 over sine. This is what we know. All right, so if we obtain it from 1 over sine, it means 1 over cosec, it's a sine. This one, 1 over cosec, so there's a negative there, so it's negative. We said 1 over sine, it's cosec. So 1 over cosec, it's a sine, which is negative sine what? Negative sine 3x. Here we are just changing this, all right? What it means. Then we are supposed to find the derivative now. What is the derivative of what? Of sine 3x. The derivative of sine 3x, this is going to multiply here. So it's going to be minus 3 cos 3x, all right? So we know that sine changes to cos, but already there's a negative that is already there. So that's why it's what? Negative 3 cos 3x. So this was going to give us negative 3 cos 3x. Here, negative 3 cos 3x. All right. Let's move on to another one. 1 over cot. So there we have got 1 over cot. This one, 1 over cot x. We know that 1 over tan, it gives us what? A cot. So it means 1 over cot is a tan. So this 1 over cot, it gives us tan x. But what is the derivative of tan x? Remember, the derivative of tan x is sec squared. Even from your formula sheet, this one you are given. So this was going to give us sec squared, all right? This one was direct plus sec squared x, okay? Let's move on. Let's move on. All right, then we also have another one, negative 1 over sec, okay? 1 over sec, what is 1 over sec? We know that 1 over cos gives us a sec. So 1 over sec, it gives us what? A cos. So this was supposed to give us minus cos x. But what is the derivative of cos x? The derivative of cos x is minus sine x. So it's going to be minus what? Minus sine x, which is going to be a positive sine x. So the derivative of this whole part was going to be a positive sine x, all right? Positive sine x, okay? Then let's move on to the other one. Now we've got sine 2x over cos x, all right? On this part, sine 2x over cos x, all right? Remember that sine 2x is equal to 2 sine x cos x. This is the identity, 2 sine x cos x. We talked about this, all right? Over what? Over cos x. So this will cancel. we remain with what? With the 2 sine x. What is the derivative now of 2 sine x? That is the question. The derivative of 2 sine x is what? Is 2 cos x, all right? So the answer there was supposed to be 2 cos x. The derivative of 2 sine x is going to be 2 cos x. All right, so this is 2 cos x. Then another one, it was 3 over 2 ln x. Remember, the derivative of ln, it's 1 over x. So it is going to be minus 3 over 2 times 1 over x. The derivative of ln is 1 over x. So it will be minus 3 over 2x. So this will give us minus 3 over 2x. So we're going to have minus 3 over 2x. All right. Then the last one is minus 1 over 3p. So there we do not have x, it's just a constant, and you know that the derivative of a constant is equal to 0. So that was going to be minus what? Minus 0 in that case. All right, so that was our question 4.4. We're supposed to find the derivative of each. And I told you guys to find the derivative of each, you must be able to simplify each term before you find the derivative. It is the same thing, even on your integration. You must find the first simplification. So this is what we're doing by simplifying each, then we find the derivative of each. So that was the derivative, and this derivative, they had a lot of calculations actually this time, which was fine, because here you just need to know each derivative, and you've got 8 marks for that. So guys, it was just an advantage if you were someone who was in good books with these derivatives. It was an advantage type of a question, this one. It was an advantage type of a question that you had to apply in this case. Okay, then number 5, it was the integration. All right, so the whole of this part was integration. Sketch and calculate the magnitude of area enclosed by the graph of y is equal to sine x for the interval from x is greater or equal to 0 but less or equal to 180, from 0 to 180. Okay, that was 7 marks for that. Okay, let's see. The graph of y is equal to sine of x. We actually know this graph from our N3. So this was not a problem to us. So it was a nice question also, because this graph, it was something that we are used to. But only thing that you're supposed to consider is that you are no longer having a full graph of sine. Remember, our graph of sine is supposed to be like this. All right, I'm just gonna have a sketch graph. Guys, this one, we are used to this graph. All right, so to this graph here. So I'm just gonna have a sketch. All right, so this is our x-axis, this is our y-axis. All right, so we're gonna have x and y like this. We know that the graph of sine is supposed to be like this, from 0 to 360. All right, whereby this is 0, this is 90 degrees, this is 180 degrees, 270 degrees, 360. But there they wanted us just from 0 to 180. So meaning to say this piece here was not involved. All right, the piece, the other piece here down was not involved. You just needed from 0 to 180 degrees. All right, where we know that this one corresponds to 1. So this is the graph of sine. Y is equal to the sine of x. This is your sketch, okay? If you do not understand this graph, what you're supposed to do was to use your table. The graph of sine of x, just put in your x values, y values, 0, 90 degrees, 180 degrees. Substitute, you're going to have a 0, a 1, and a 0 here. You mark those points, you join them. You're going to have a curve like this one. All right. So they are saying we are supposed to calculate area from this graph that we see. So meaning to say we are going to need a representative strip that we are going to use in calculation of our area. And this can be best in the x-axis like this. This is where we're going to have our representative strip, and we can calculate our area in the x-axis. So the area is going to be given by the formula. Remember, that's the integral of y with respect to x given the limits a and b. All right, so like I said, we have our limits from 0 to 180. So whatever that you're going to do in this case, we can even change our values, these ones to radians, mostly, or when you're dealing with your integration, just change radians so that this can be pi. So we're gonna have our area with respect to x as the integral of y, which is the sine of x. So this is the sine of x with respect to x, with from our limits 0 to pi. So pi simply represents 180 degrees. All right, it's just one and the same, guys. Okay, one and the same thing. Okay, from 0 to pi. So what we are going to have in this case, like I say, this pi is just same as what? 180 degrees, or 180 degrees, just one and the same thing. Okay, so remember the integral of a sine. If you integrate a sine, it changes to a negative cos. So that will be a negative cos. The integral will be a negative cos of x. So we're going to apply our limits in this case from pi, which is 180, to 0. That is upper limit minus the lower limit. So you're just going to substitute minus cos of the upper limit, which is pi, or 180 degrees. All right, let me just use the pi that I've already chosen, minus the lower limit, which is minus cos of what? Cos of 0, like this. Okay, so this was going to give you 2 square units. Remember, this is area. This is going to give us 1, and you've got a minus 1. So minus the plus is going to be 1 plus 1, which is what? Which is a 2. So this is what we're going to have at the end. Even if you substitute cos 180, is just one and the same thing. All right, in your presentation. So this is how we're supposed to evaluate this. For the marks that you're given, 7 marks, I think this one was nice. It was a nice question. If you understand your integration, just there's no much work in there. There's no much work in that was to be considered. Anyways, let's see the next question. 4 marks for this one. Evaluate the integral. We had this part on our derivatives to differentiate something of this nature, but this time they want us to consider as the integrals in this case, to find the integral of this, and we're given the limit here, -1 to 0. All right, how is this a -1? All right, because it's supposed to be, the upper limit is supposed to be a positive. But according to what you're given, this is what you're given. They gave us as -1. We use it like that. Okay, we are not even afraid of that. This is how they gave us. So we just use it like that. But you're supposed to have the bigger value on top, upper minus lower. But that is it for this one. It's fine. Let us integrate 5.2. The integral of 3 to the exponent of -2x. All right, with respect to x. Remember, we had a derivative about this. What about the integral? All right, it follows that I told you that the integral of k a to the exponent of f of x, if it is the integral of this with respect to x, it is going to give us k times a to the exponent of f of x. It remains as it is on top, right? But on the denominator, you're going to find the derivative of f of x. So you're going to find the derivative of f of x times the ln of a, which is the ln of the best, which is what? The best, which is a. So in this case, we do not have a constant. The constant is just 1. So you're just going to integrate direct. So this was going to give us a to the exponent. This one is just going to remain as it is, 3 to the exponent of -2x. All right, as you know, definitely there's going to be a cost of integration, but for the limits, there's no need for you to write the cost of integration. All right, so this is over the first derivative, as we can see here on our formula, first derivative of what? F of x. So the f of x is the function of x, this one, -2x. What is the first derivative? The first derivative is going to give us -2 times the ln of a, which is the ln of the base. A is the base, and our base in this case is 3. So it is going to be the ln of 3. So that is your derivative in this case. Then you apply your limits from -1 to 0 as we are given them like that. Then that's it. That was your question. Just know your integrals, guys. As you can see, it's an advantage to know your integrals. So if you substitute -1 here in place of x, this will be 3 to the exponent of a negative 1 times -1, -2 times -1, all right, which is a positive, or just write -2, -1, which is fine. Everything over -2 ln x, of which you can write the negative on top, or you can even write it like that, -2 ln 3, all right? So this is your upper limit, minus, you're gonna have on the lower part, you're gonna substitute as 0 here. So it will be 3 to the exponent of -2 times, which is 3 to the exponent of 0 over -2 ln of 3. So that's it. That's you and the calculator there. You were supposed to obtain something like -3,64095, something like that, which is 641 to 3 decimal places. All right, so that's a negative because as you can see, we are having a reverse of what we actually know in terms of the limits. So that's why we are getting what? A negative answer. It's fine like that, okay? It's actually fine. So that was it. Let's consider question 5.3. Integrate. All right, so we are integrating each and every term. So just like that part on our derivatives, we're going to integrate also this. Just gonna integrate each part. All right, so 5.3, you're gonna have the integral of e to the exponent of x. We are back to that part and I erased it, but let me just rewrite. All right, sorry for that, guys. So like I was saying, here we are supposed to integrate each part, each and every part you're going to be able to integrate. I just hope with this network thing is, to be affecting this network. So we say the integral of k a to the exponent of f of x, like this, with respect to x, is going to give us ka to the exponent of a to the exponent of f of x, like this, over first derivative. Gonna have the first derivative times the ln of the base, which is the ln of a. All right, so meaning to say here on e to the exponent, we've got e to the exponent of 3x, this one. So it is supposed to give us e to the exponent of 3x as it is, okay? You're gonna have e to the exponent of 3x as it is, all right, over what? The first derivative of f of x, the first derivative of 3x is 3, all right, times the ln of the base, which is ln a, our base is e, so it's gonna be ln e, and we know that the ln of e, it gives us what? A 1. So meaning to say this whole part that we are seeing here, it was going to give us e to the exponent of 3x over what? Over 3. 3 times 1, which is just a 3, okay? Let's move on to the other one. So this is it. The same thing on this part. So the constant there, which is the k, so it's going to be 3. So that's 3 times a to the exponent of f of x. So this is a to the exponent of f of x, which is 3x, as it is our f of x there is what? Is 3x. A to the exponent of 3x over the first derivative of f of x. This is our f of x. Remember, what is the first derivative of this? Is 3 times the ln of the base, which is the ln of our base, which is a, the base, which is this one, which is a. So it's ln of a. So this one and this one, we're going to cancel. So we're going to have plus, we're going to have plus a to the exponent of 3x over the ln of a in simplest form, okay? Let's move on to this. It was like one and the same thing throughout. We have got the same thing here, so it's gonna be negative 10 to the exponent of 2x, which is our a to the exponent of f of x, over the first derivative of f of x, which is the first derivative of 2x, which is 2, times the ln of the base. Our base there is 10, so it's ln of 10. So that's it. There's nothing that can cancel here, so this one, there's nothing, so it's just going to be minus 10 to the exponent of 2x, everything over 2 ln of 10. There's nothing that we're going to do on this part. We can't cancel anything on this part. There's nothing that we're going to cancel. All right, let's consider this one. 1 over the cube root of x. We know that this represents x to the exponent of minus a third. This is the one that gave us 1 over x to the exponent of a third, which is the same as the cube root of x. But for this x now, it's a normal integration. Remember, your normal integration is that you have to add 1 on the exponent. So if you add 1 on the exponent, it is going to be x to the exponent of 2 over 3 over the new exponent, which is 2 over 3. So that means we are dividing 1 divided to 2 over 3. If we divide 1 to 2 over 3, it is going to give us 3 over 2. And the x is going to remain as it is to the exponent of 2 over 3, or the cube root of x to the exponent of 3 if you want. All right, then don't forget the constant of integration, because you are not given the limits in this case. So you have to consider your constant of integration. So that's it, 5 marks for that. 1, 2, 3, 4, 5 marks. Okay, that's it. 5.4, simplify the integral of cos squared x minus sin squared, of which we talked about this identity. A lot of times, just from our identity of cos 2x, remember that cos 2x, it has got 3 identities. One of these identities is the one that we are given, cos squared x minus sin squared x. Yes, we know that we've got this identity of 2 cos squared x minus 1. We've got the identity of 1 minus 2 sin squared x. Yes, these are the identity, but if we check this whole thing that we see here, this whole part here, it's cos 2x. So they're just, instead of them giving us cos 2x, they just want us to struggle to figure out what is that identity that is given there. But it's just one and the same thing. So this is simply the same as the integral of cos 2x. All right, with respect to x. So that's it. Once we are at this stage, guys, we are done. Remember the integral, of course, cos changes to a sign. So it is going to be sine 2x, and we divide by this number that is affecting your sign. So it's going to be, remember, on derivatives, you multiply this side by the number, and integration is the reverse. So you divide. All right. So we are simply saying the integral of cos bx with respect to x is equivalent to sine of bx over b. All right, plus the constant of integration, plus the constant of integration. That's what I'm simply saying. Okay, if it is sine, it's going to be negative cos b x over b. Okay, we divide by b. We divide. Derivatives, you multiply. Integration is the reverse. So that's it. 4 marks for that. Just to do this, 4 marks, just a matter of knowing your laws. Know your laws and know your identities. All right, so this was our question paper, guys. This was our question paper. So let me know, guys, on the comment section, the members of Maths Zone African Motives and those who are part of the subscribers. Remember, also have the members. Let me know on the areas that we can work with for those who are to advance to Mathematics N5. You can check, there are videos there for Mathematics N5. But if you're a member, you can now start to ask for the questions, for the topics to be done for Mathematics N5. And maybe you're also a member, but you did not manage to, you're seeing that the marks that you were planning to have are not in line. You want to rewrite this. It's still another opportunity for that, to do that. But you can also be doing that as we are advancing with other subjects, writing also the maths as the 5th subject. It is very, very possible. So let's try to do that. If you're advancing, let us know the areas that we can work on. But as we can see, there are some of the areas that are already there for N5. So let's check them. Yes, let's see the introduction. I think there are so many videos on mathematics for just introductions. You can watch those videos so that you see what is now the difference that you have in mathematics N5 from what you had in mathematics N4 in terms of your derivatives, your integration, these areas. Now you shall be calculating volume in N5. So it's something else that you just need to know. So let's see them. Let's watch and let's see where we can work in addition to what we already have.